Hello. I want to welcome all our emergency responders and trainers to the TransCare Chlorine Safety Tour, brought to you by the members of the Chlorine Institute. As responders who may face chlorine-related incidents and those who train them, you face many challenges. Your actions must combine a clear understanding of the properties of chlorine and the systems that are used to store, transport, and carry it. In an emergency, you must be able to act swiftly, effectively, and safely. That is exactly what this program is designed to help you to do. Our goal is to give you the knowledge and hands-on experience that enable you to respond to a chlorine-related incident in a way that is safe for your community, your team, and you. My job involves some of the most exciting work we do in promoting chlorine safety, including our work with TransCare and ChlorEP, the Chlorine Emergency Plan. When I earned my degree in chemical engineering at the University of Tennessee, like many new graduates, I thought I knew something about safety. Later, when I was a frontline supervisor and incident commander at a manufacturing facility, I learned that hazmat safety requires a constant training and a clear commitment to safety by everyone involved in both operations and emergency response. That's why I'm especially pleased to be working with the Chlorine Safety Tour. It involves outreach to people like you who help keep us safe. The members and staff of the Chlorine Institute, thank you for your service. The Chlorine Safety Tour is being brought to you as a part of the TransCare Outreach Initiative. TransCare stands for Transportation Community Awareness and Emergency Response and is a voluntary national effort that focuses on assisting communities to prepare for and respond to a possible hazardous material transportation-related incident. The organization began with 2 partners in 1986 and has expanded nationwide and provides classroom and hands-on training, emergency planning assistance, technical information, and many other valuable resources. For more information, including information on upcoming training events, please visit www.transcare.com. The Chlorine Safety Tour training program consists of 4 important modules. The first module provides basic information on chlorine properties and emergency response. The second module discusses chlorine tank car and rail safety. The third module explains the proper and safe use of emergency kits A and B to stop leaks from chlorine cylinders and ton containers. And the fourth module explains the proper and safe use of emergency kit C to stop leaks from valves and fittings on a chlorine tank car or cargo tank. These modules are taught by railroad and chlorine industry experts who were selected for this program because of their knowledge and experience. We thank them for volunteering to be a part of this very important effort. In addition, I want to thank the Class 1 railroads for their support of this National Safety Tour, with special thanks to CSX and BNSF railroads for their support in producing and distributing this video. I also want to thank the Firefighters Education and Training Foundation for partnering with us to provide their hazmat safety train equipment for use during the tour. And finally, I want to thank the TransCare, Chemtrec, and Canutech organizations for their continuing commitment to enhance the safety of our nation's responders and the communities they serve. Our first training module on chlorine properties and emergency response is presented by Dan Thompson. Dan is the Transportation and Distribution Manager for Occidental Chemical Corporation. Dan also chairs the task group at the Chlorine Institute that developed and oversees the Chlorine Safety Tour.
The objectives of this presentation is to introduce the Chlorine Institute and the ChlorEP program so you understand what that is and how that resource can be made readily available to you. It's also to provide an overview of chemical properties, uses, and the hazards of dealing with chlorine. To provide you also with an understanding of how chlorine properties affect how you respond to a chlorine emergency. The exposure treatment will be covered along with security concerns when you go on a chlorine emergency site. We want to provide you also with an overview of the resources that are made readily available to you in case you're in an emergency. Remember, when you go into a chlorine emergency, you're not dealing with it alone. First of all, I mentioned the Chlorine Institute. Well, what is the Chlorine Institute? Well, it was established back in 1924, and it's a nonprofit technical trade association. It has over 200 members, and it's a worldwide organization, not just North American. It's focused on safety and handling of chlorine and what we call mission chemicals that are normally associated or produced with chlorine, all the way from production through handling, distribution, and final use. Many of these pamphlets are available on their website, and they're available for a free download. Those resources are available to you from any place you have access from a computer. Chlorine Institute deals with what is known as the chlor-alkali industry. The chlor-alkali industry is named because it's how chlorine is normally manufactured. Usually it involves introducing some sort of a brine solution that's either sodium or potassium. It's ran into a cell, it's hit with a large amount of DC current, and it fractures the molecular bond. It produces chlorine, sodium hydroxide, or potassium hydroxide, depending on which brine is chosen, and hydrogen. Therefore, you get the term chlor-alkali industry to indicate how it's normally produced in conjunction with sodium hydroxide or potassium hydroxide. Chlorine Institute's accomplishments are many. One of the biggest things that they did early on in the organization is they actually moved to standardize all the chlorine shipment containers. Prior to 1929, manufacturers' containers were all different depending upon who the manufacturer was. So the first really big change in the industry was to standardize those containers. That allowed us to develop capping kits for emergency use that could be utilized regardless of who the manufacturer shipper was. In 1972, they developed what was called the CHLOREP network. Now, CHLOREP stands for Chlorine Emergency Plan. And what it is basically a volunteer mutual aid organization made up of manufacturers, shippers, distributors, and end users of the product that join in to make sure that we can get the most rapid response possible to a chlorine incident. The Chlorine Institute also I referred to as a technical trade association because of the pamphlets that they published. There's many pamphlets available to you that go into all kinds of details about the manufacturing, handling, safe distribution, and use of all the emission chemicals. They also have available other educational materials like videos that can be downloaded or ordered from the Chlorine Institute. These include things like how to install the A, B, and C kit, as well as the First Responder DVD. Chlorine Institute also works closely with the other regulatory agencies like the DOT, OSHA, the EPA, and the DHS in order to advance health, environment, and the safe handling and management of chlorine and our emission chemicals. The Chlorine Emergency Plan, or the CHLOREP mission, is basically to prepare and educate to ensure that we have an effective emergency response to every chlorine incident. They also ensure that they have a timely and professional response guaranteed at each one of those incidents. The strategy that we use to accomplish the missions of CHLOREP are that we assist in responding to state and local requests for training on chlorine and chlorine-related products, much like we're doing with you here today. We also provide training opportunities for our CHLOREP team members. For 1 week out of every year, we go down to a chosen site to do hands-on training with all of our CHLOREP team members to ensure that they have adequate training to be able to properly respond to a chlorine incident. We also ensure that we have CHLOREP coverage that covers all of North America, not just the United States, but also Canada, to make sure that we can get responders on scene as quickly as possible to any chlorine incident. We also maintain a contractor verification program that I will go into more detail on later. If you look at the CHLOREP sector map, you can see what I just talked about earlier, that we have all of the United States and Canada covered, that each sector belongs to some sector team leader who's available to respond in an incident in their sector. For instance, I am the team leader for Sector 12 in the center of the United States. These sectors can cover multiple states and even can cross borders depending on who is the closest resource available. All that you need to remember is if you will contact Chemtrec, they are fully informed and aware on how to activate the CHLOREP team. Wherever in the United States or Canada that you have a chlorine incident, someone on site will contact Chemtrec. Chemtrec knows who has the closest available sector to that emergency. They will contact that sector team leader, and those resources will roll. You'll be contacted back at the scene in a very short period of time. It works very well. We've had actual responses to chlorine cars that shipped out of Canada that were well into the United States, where the sector team that was closest to the cars at the time of the incident responded in a timely fashion. So remember, that's your quickest way to get resources available to you if you're at a chlorine incident. I said we would talk more at length about the ChlorEP emergency response contractors. We refer to them as level 3 contractors because these contractors have the skill, the equipment, the tactics, and training to be able to respond to serious chlorine events, such as a breached container or actually doing a transfer from one chlorine container that's damaged into another so it can be shipped. There are currently only 3 level 3 contractors that are verified, and they're all in the United States. These are the folks that if myself as a ChlorEP team leader need additional resources at a chlorine emergency, these are the personnel that I'm going to contact to bring me additional help and resources. The ChlorEP program also contains Canadian contractors that we refer to as level 2 contractors. You can see the current organizations that are now level 2 in Canada. These contractors are also verified on a 2-year basis, but they won't deal with anything as serious as a damaged container, or they won't do field transfers of chlorine. However, they are fully capable of dealing with a wide variety of chlorine emergencies, such as packing leaks, valve leaks, and they're very competent in installing the 3 kits, the A, B, or the C kit, if need be. We refer to chlorine as a very essential chemical. It's very critical because it's integral to components of nearly everything that we touch in our everyday lives. It's actually utilized in the production of literally thousands of different products. One of the most important things that we do with the chlorine molecule is that we disinfect water so we make it safe and disease-free. This application of chlorine is probably one of the most important. We've been doing it now for over 100 years safely, and it's been called the biggest step forward in mankind's health improvement. It's also used to produce 93% of the top-selling pharmaceuticals and drugs. And for nearly all of these applications, there is no substitute. It's used as a germ-destroying disinfectant in homes and institutions and hospitals. It's also used to produce 86% of the crop protection herbicides and insecticides. It's used indirectly in 40% of all U.S. industries and used indirectly in virtually every industry there is. One of the biggest uses of chlorine that surprises a lot of people is plastic. A lot of chlorine is utilized in the production of PVC and vinyl plastics. It's used also in the renewable energy and as well as the recycling industry. And if you look at it as a whole, it's a pretty important chemical based on the fact that it's utilized to clean our water for us. It's used in the production of our food. It's a primary component in many of the medicines that we take. So without chlorine, our life would be extremely different. The quality of life would be reduced significantly. If you look at this slide, you can see where the uses of chlorine as a percentage of the total production. As I mentioned earlier, one of the biggest uses for chlorine is the production of PVC plastics. Up to 42% of the chlorine that's produced in this country is used for that purpose. Another major use would be organics. Approximately 26% of the chlorine goes for the production of organics. And these include a wide variety of different products like the insecticides, herbicides, productions of refrigerant would all fall into the organic section. If you look at the inorganic section, that also makes up a rather large percentage at 19. Some very important inorganic products would be things like HCl, which is a very basic industrial chemical that's utilized in many, many different industries in the United States, including the production of oil and gas. You'll notice the disinfection is only 4% of the total. Even though this is a very important contribution that chlorine does, it doesn't take very much of the product manufactured to perform that. One of the reasons for that is that it really takes so very little chlorine to purify water. There's a fairly large municipality that we serve that in the summertime during the peak usage months of water, it still takes them 6 weeks to go through a 90-ton chlorine car. You think of the millions and millions of gallons that get treated with 90 tons of chlorine, it makes it a very affordable option. You'll notice pulp and paper only amounts for 2%. That's been kind of a reducing segment over time. It used to be closer to 4%, and then other miscellaneous items about 3%. But as I mentioned earlier, the bulk of the chlorine produced goes in the manufacturing of PVC. Chlorine and bleach are often used interchangeably by a lot of different people, but they're two very different products. To start with, if you look at the placards on the slides, you can tell there's a significant difference just by the division they belong to. Chlorine on the left, you can see, is a poison inhalation hazard. You can also tell by the 2 class that it's a compressed gas. It normally is a bigger concern to a responder than most of the other classes because it means it's going to expand. It's a compressed gas. If you look at bleach, on the other hand, it's only a class 8 corrosive. It's an aqueous solution that really isn't very vaporous. Chlorine has a very strong, pungent odor, and we use the term bleach-like to describe the smell, which helps contribute to the confusion that people have. That chlorine is not the same as chlorine bleach. Chlorine is used primarily in industrial applications, and it's shipped as a compressed liquefied gas in pressure containers. It represents a lethal exposure risk, so it's considered a hazardous material. Bleach, on the other hand, is primarily used as household use or around personnel. It's an aqueous solution, which means it's in water, so it doesn't really have any very much of an inhalation contribution. It's basically a corrosive to the human. It's a very moderate irritant. So you want to keep in mind these are two very different products that have very different response requirements. Chlorine properties. Well, you have to look at the properties individual as a liquid or as a vapor. If you look at chlorine as a liquid, probably none of you have seen liquid chlorine. It doesn't stay liquid when it escapes into the environment very long as a rule. But if liquid chlorine is considered amber in color, it looks a lot like beer. It doesn't foam, and it doesn't look like dark beer, but it looks like standard light beer, basically, without the head. It's a heavy liquid. It's about 1.5 times heavier than water. So when you have a chlorine release into water, you know that it's going to sink. It becomes a solid at about minus 150 degrees Fahrenheit at its freezing point. But the more important property to remember is that it becomes a vapor or gas at about a minus 29 degrees Fahrenheit, known as its boiling point. So you know that if you see liquid chlorine, it's below minus 29. So it represents a thermal concern. Chlorine has a very high coefficient of expansion. 1 volume of liquid equals about 460 volumes of vapor, which, as I spoke about earlier, based on the class, a small amount of liquid makes a very large release and a very significant problem to deal with. Chlorine has a vapor pressure when you go above its boiling point. Like most materials, it increases rapidly as the temperature rises. Liquid chlorine, as I said before, if you see liquid chlorine at atmospheric pressure, it has to be very cold at below minus 29. When you look at chlorine properties when it's in the gaseous state, you'll notice faint yellowish color emitted from very low concentrations of chlorine vapor, and it becomes greenish yellow at higher concentrations. As a matter of fact, experienced people may refer to chlorine releases as far as their concentration by their level of greenness. The greener the concentration, or the greener the color, the higher the concentration is. One of the big things to remember about chlorine vapor is that it's about 2.5 times heavier than air, significantly heavier than air. Chlorine vapor is so heavy that it has a tendency to act more like a liquid than it does a vapor. And in some significant releases, it's been noted that chlorine vapor will actually go upwind if it can go downhill. So when you're responding to a chlorine emergency, you want to be very concerned about elevation, especially if it's in a municipality that may have storm sewer drain systems. Could easily enter those drain systems and move through that system. Remember, it will concentrate in very low areas. Chlorine vapor is generally not visible below 25 part per million concentrations. So if you can see chlorine vapor in a release, you know it's above that level of concentration of 25 parts. You also want to keep in mind the IDLH for chlorine is only 10 parts per million. So if you can see the vapor, it's a lethal concentration. The gas pressure of chlorine inside of the pressure vessel it's shipped in is going to be proportional to the temperature. So as the temperature rises, so does the pressure. That's very important to remember if that chlorine container has been exposed to a fire. One of the most important things you want to remember when responding to a chlorine release is don't spray water directly on the leak source. Water and chlorine make corrosive hydrochloric acid. Chlorine containers are all made of steel. The transportation containers are. Hydrochloric acid is very corrosive to steel. If you introduce water on the chlorine source, you've now created a very corrosive environment that's going to make your leak much worse. Another problem you run into when you put water on chlorine is it reacts. And like most reactions, it gives off heat. If you heat the chlorine, it's going to vaporize even more. You're going to increase the problem you have to deal with. Another thing we'll talk about later in a slide is you really can't absorb much chlorine vapor into water. It's not worth the effort. I said wet chlorine is very reactive and corrosive to steel. That doesn't mean that there's liquid water in that chlorine to get wet. It doesn't have to be anywhere near that level to be considered wet. Typically, we consider chlorine to be wet anytime it has a moisture content of 150 part per million or more. Now, that doesn't sound like a lot of water, but you want to remember chlorine is typically shipped with a water content of 20 part per million or less. Not unusual for it to be at 10 parts per million. That would be what we would consider dry chlorine. A dry chlorine is actually compatible with most materials like carbon steel, and that's why it can be shipped in carbon steel containers. However, it does react violently with some metals like titanium, aluminum, and tin. So you want to keep that in mind, that if you're responding to a chlorine leak, you don't want to take your titanium driver with you. Also remember that chlorine reacts violently with steel at temperatures above 450 degrees Fahrenheit. That 450 degree Fahrenheit number was actually generated in a laboratory, and unless the steel is crystal clean, it lowers that reaction temperature. Very, very much less than 450. That's why most chlorine producers won't let chlorine get above 200 degrees Fahrenheit. They want to have a large buffer between it and 450. Because in a chlorine iron fire, you have a very difficult problem to deal with, because the iron is actually acting as the fuel, the chlorine is acting as the oxidizer, the ignition point occurs as a chemical reaction. And since chlorine is acting as the oxidizer, it doesn't need oxygen. That reaction can occur and that burning can continue underwater. That makes it a difficult problem to deal with. That 450-degree temperature can be lowered very significantly if it's a highly separated form of steel like a mesh pad or steel wool, and we'll see that later in a video. Chlorine can also support combustion if you're above 480 degrees Fahrenheit, which can come into play if it's involved in a fire. Now we're going to watch a short film that will illustrate some of the properties that I've just talked about. We're going to take a look at a chlorine iron fire with steel wool, which will actually burst into flame at room temperatures when submerged in liquid chlorine. Chlorine gas, as I talked about, is a yellowish green color. And here's liquid chlorine. It's an amber color. It's about minus 29.3. You'll see the vapor coming out of that beaker is so heavy it will barely clear the top of the beaker. Wet chlorine is corrosive, as you can see in this real-time video being applied to a steel washer. As far as reactivity, this video here will demonstrate steel wool and chlorine reaction. The next video is grease and oil. As I said, chlorine is very high oxidizing material. We test for chlorine leaks utilizing aqueous ammonia vapor. As you can see in the video, it's a rather violent reaction that gives off a lot of white vapor to clearly indicate where those leaks are. You can actually smell chlorine as little as a half a part per million. You can actually find leaks of chlorine lower than that utilizing aqueous ammonia vapor. Chlorine reacts violently with hydrocarbon oils and greases. For that reason, any lubricants that are going to use that can be in contact with chlorine have to be fully halogenated greases and contain no hydrocarbons. Also, silicon-based greases and oils will react with chlorine. Detergents and soaps react with chlorine. It's one of the reasons also that we use aqueous ammonia to find chlorine leaks and not detergents and soaps. Chlorine will also react violently with ammonia. That's one of the reasons that we use it when we're checking for chlorine leaks. But we only use the vapor from the aqueous ammonia. We don't put liquid ammonia on chlorine leaks. Finally, divided metals. We saw the video of the steel wool erupting at room temperature. Chlorine will also react with activated charcoal. Now we're going to watch a video that was shot at the Dugway Proving Grounds in Utah that actually shows a chlorine release of liquid chlorine of approximately 1 ton. You'll see it only takes about a minute for the entire contents of the tank to empty, but the vapor will continue to expand and move well after that. The tank we're going to look at is only about 8 feet off the ground on the stand, so you can keep that in mind when you look at the amount of rise that the vapor does during the release. It's also in a dished out area, which has a little bit of a tendency to act like a bowl, but you'll notice that the chlorine, being so much heavier than air, wants to rest in that bowl. We're going to see the video go through, and it's going to go through segments of the first minute of when we're going to see the liquid being sprayed out of the tank, which it'll be emptied. Then we'll look at segments of 5 minutes, 15 minutes, and 30 minutes. Here you can see the chlorine escaping rapidly through the 2-inch ball valve on the bottom of the tank. But you'll notice, if you look at the elevation of the tank, it's barely rising more than about 2 feet above the ground. It's also pretty much staying within the confines of the dished out region around the tank itself. At the 1 minute mark, approximately, you can see that the liquid is gone from the tank. At the 5 minute mark, you can see a fairly oval outline of a concentration of the chlorine vapor. At the 15 minute mark, it's significantly reduced, but it's still there. If you look at the 30-minute point, you can no longer see any chlorine vapor under the tank, although in actuality, it's very likely still above 10 parts per million, which was the IDLH for chlorine. It's also interesting that this chlorine stayed at about 2 feet above the ground. And to give you an idea how little of the chlorine raised much above that level, during one of the tests, a flock of birds actually flew over the test site and landed on top of the tank and sat there for a period of time. Even though there was a very lethal concentration of chlorine at the bottom of the tank, they showed no ill effects and flew off. Now we're going to see a side-by-side comparison of a much heavier than air material, chlorine at 2.5 times, versus ammonia, which is only about half the weight of air. Even though both of these chemicals are considered poison inhalation hazards, you can tell by watching the video there's going to be a significant difference in how you'd respond and manage these emergencies. You can see very quickly into the release scenario, the chlorine is acting again as a very heavy agent on the bottom of the bowl area, while the ammonia vapor has already expanded to a point where you can barely see the tank that it's being emitted from. Volume of ammonia continues to increase and expand and engulfs the entire viewing area of the camera. So you can tell that there would be a lot of different criteria you'd have to consider when responding to ammonia versus chlorine. The way that it rises makes it a big consideration for any elevated surface, as opposed to chlorine, which is a significant concern when it's running along the ground or lower elevations. The chlorine vapor virtually reaches the end of the dished area and pretty much sits there, whereas the ammonia vapor releasing has engulfed the entire viewing area of the camera, and you've lost view of the tank. What are the environmental hazards when you're dealing with chlorine? Well, chlorine itself is not actually a naturally occurring element. Chlorine element is never, ever evident by itself. It's always joined up with some other molecule. It's way too reactive for it to remain in its state as an elemental chlorine. Most of the time, it's actually tied up in a molecular bond with sodium chloride salt. Matter of fact, that's how we actually begin the chlorine production process, is with salt. If you mix chlorine with water, as we talked about earlier, you will end up with corrosive hydrochloric acid. So you want to keep that in mind any place where the chlorine is going to meet a moisture barrier, whether that's dew, fog, or just water. Whenever you come upon a site where there's been a chlorine release, you want to look for evidence that there's been chlorine contact. One of the ways that's evident, when you look at vegetation, you'll see bleach spots on leafy plants. And even though the plants look like they're under a lot of duress or stress, normally the plant won't die from chlorine contact and it will fully recover later. You want to remember too, the inhalation effects of chlorine is identical on other animals as it is with humans. So if you come upon a chlorine release scene and there are dead animals in the area, it's a pretty good indication that lethal concentrations of chlorine have been there. And you need to take precautions to protect yourself. The water solubility of chlorine I mentioned earlier is not good. In the laboratory, they've only been able to get chlorine to absorb into water at a point of only about 6.93 pounds per 100 gallons of water. That was done in a laboratory under ideal conditions. If you're in the field trying to do it without ideal mixing, you won't even get anywhere near that point. So you can tell trying to absorb chlorine into water is a total waste of time. And the biggest problem you're going to introduce is now you've got wet chlorine, which we talked about as being highly corrosive. It will also be corrosive to human skin and cause significant burns. One of the other things to keep in mind, it doesn't take very much chlorine into water, as chlorine to have effects on aquatic life. As little as 0.1 part per million will affect very fragile aquatic life. And for this reason, the DOT lists chlorine as a marine pollutant. As far as exposure to chlorine, if you've been exposed to an acute level of chlorine in a single contact incident, what kind of hazards are there? Well, it's a toxic gas, as we talked about. Your primary concern is always your respiratory tract and eye contact. Both of these surfaces are highly humidified, and they actually create hydrochloric acid. Therefore, you can suffer chemical burns, not only from that contact, but the fact that chlorine is an oxidizer, and if you have anything on your body or person that it can react with, then it can burn you. You also want to keep in mind that if the chlorine is in the liquid phase, as we talked about, it's at below minus 29F. So frostbite is a serious concern. One of the good properties of chlorine, though, is the extremely low threshold that you're going to be able to detect its odor. It can be as low as 1/4 of a part per million for some people, generally accepted as a half part that most people can smell, and the rare individual that can't smell it at 1 part. So it has excellent warning properties because of the relative distance between those numbers and the 10 parts per million, which is the IDLH. You are not going to accidentally walk into a lethal chlorine concentration. It has very good warning properties. One of the first areas that's going to be affected in a chlorine release is going to be respiratory. It's the most sensitive part of the body in regard to exposure to chlorine. Secondary to that will be your eyes. That's why the IDLH for chlorine is actually as low as it is. You can actually easily survive through a 10 part per million chlorine concentration, but one of the problems is at about 8 part per million, your eyes will start watering and tearing to a point that you virtually can't see. Therefore, you cannot typically get yourself out of that environment, and therefore you have such a low IDLH rating. The impact of exposure to chlorine is like most chemicals. It depends upon the dosage, which is a combination of the concentration and the time of duration. The impact of an exposure to chlorine is dependent on the dosage, which dosage depends upon the amount of the concentration as well as the duration of the exposure. So what are the exposure limits for chlorine? Well, according to the American Conference of Governmental Industrial Hygienists, the threshold limit value for exposure to chlorine is 1/2 part per million on an 8-hour time-weighted average. The OSHA personal exposure limit is also 1 part per million as a ceiling. The conference also says the threshold limit value for a short-term exposure limit is 1 part per million. What's the IDLH for chlorine? Well, it's 10 parts per million. So you see there's a pretty significant difference between the allowable exposure and the IDLH. Is chlorine considered a carcinogen? No, it's not. Not by OSHA, NIOSH, NTP, or the EPA. What are the clinical effects from an acute exposure to chlorine? Well, if you're in the neighborhood of 0.2 to 3.5 part per million, that's considered odor detection. At 1 to 3 parts per million, you're going to notice mild mucous membrane irritation that can be tolerated up to 1 full hour. 5 to 15 parts per million, you're going to have moderate irritation of the respiratory tract. Now, that term moderate that's used in that particular measurement refers to how rapidly you can recover from that exposure. Because I can guarantee you, if you're exposed to 15 parts per million chlorine, you're not going to consider it moderate. It's only moderate if it's somebody else being exposed to it. At 30 parts, you're going to have immediate chest pain, vomiting, dyspnea, and a cough occur. At 40 to 60 parts, you're going to have toxic pneumonitis and pulmonary edema can start to set in. At 430 parts, it's going to be lethal if you're in it over 30 minutes. At 1,000 parts per million, it's going to be fatal within a very few minutes. And if it's over 1,000 parts, it can be fatal as soon as 3 breaths. Treatment of exposures for people who've encountered chlorine? Well, if you're going to go in and rescue someone who's had an exposure of chlorine, you absolutely have to wear an SCBA, because your respiratory system will be attacked and you will also become a victim if you don't protect yourself. One of the first things that you have to do to get a victim to recover is you've got to get them out of that chlorine environment. They have to get to fresh air without delay so they can begin the recovery process. For a typical minimum exposure, which has minor burning of the nose, throat, and the eyes, the only thing you really need to do is to get that victim out of that chlorine environment. They will oftentimes recover in less than an hour from a minor exposure. But due to possible pulmonary edema that can set in, that person needs to be medically monitored over the next few days. It's pretty common for most producers to have a requirement that any chlorine exposure victims are going to be monitored for at least 3 days after their exposure. Continuing with inhalations, if you've had a more severe symptom from a higher exposure limit, typically will show up as a tightness in the chest, dyspnea, a persistent cough. The person will normally have a high level of anxiety, and that person's going to have to be treated with oxygen or other respiratory supportive measures because they're not going to be able to breathe normally. They're going to be fighting to breathe and bring air into their lungs. You want to make sure you get that victim into fresh air as soon as possible and get medical attention as quickly as possible. You want to monitor the victim because they're going to be experiencing a lot of respiratory distress. You want to make sure and check their airway that's open because you can have symptoms of swelling in the throat that can interfere with the normal breathing process. You want to remove any contaminated clothing the person may have on because that will constantly re-expose the victim as the vapor continues to evolve off their clothing. You also won't be able to transport that victim in an ambulance until you get them cleaned. For skin contact exposure, you want to make sure and wash the skin with plenty of water. This is one place where you actually want to use a lot of water. You want to get that off their skin so you can cease their exposure to the vapor as well as prevent future corrosion burns. You want to get their contaminated clothing off, wash the body entirely, thoroughly, rinse it. And if they continue to have irritation after you've irrigated them sufficiently or they have broken skin or blisters, they need to get medical attention immediately. If they get chlorine in their eyes, you want to wash their eyes immediately with copious amounts of water for at least 15 minutes. You're going to have to help the victim keep their eyes open because they're going to be burning badly enough, they're going to want to clamp their eyes shut. So you have to help them separate their eyelids. And I'll guarantee you they aren't going to keep that irrigation going for 15 minutes because that's going to seem like an eternity. You want to make sure they get medical attention immediately, and the victim, if it's had eye exposure, needs to be examined by an ophthalmologist as soon as possible. Keep in mind that you shouldn't wear contact lenses if you're going to be exposed to chlorine because the chlorine can break down the chemical lens material and can actually make it become part of the eye. As we spoke about earlier, one of the many pamphlets that's available from the Chlorine Institute is pamphlet 65, which gives you PPE recommendations when responding to chlorine emergencies. You want to make sure before you go into an emergency what level of PPE you should have on. First, you have to know what chemicals you're going to be exposed to. Make sure that what you're going into is actually a chlorine release and not a mixture of other chemicals. You want to make sure you have a lot of knowledge regarding the contents of the Emergency Response Planning Guide for chlorine and follow those guidelines. You want to make sure your employees are trained and experienced in dealing with chlorine emergencies before they're exposed to it. You want to develop a site safety plan before any entry is made into an area where chlorine releases occurred. Make sure you have somebody named as the incident commander so that you have a concise plan that can be implemented by a multitude of people and follow their guidelines. Some of the considerations and decisions that you have to make when dealing with a chlorine emergency is what kind of personal protective equipment are you going to have to wear to enter. You have to know exactly what state the chlorine's in, whether it's a gas or a liquid phase or some combination of either one. One of the things you will have to have on regardless of which phase it's in is an SCBA that's under positive pressure. These guidelines are all actually spelled out in pamphlet 65 that I'd mentioned earlier. If it is a gas or a vapor release, you should have on a level B suit that has self-sealing sleeves or taped. You want to make sure that you don't go into confined spaces, though, if you only have on the level B with self-sealing sleeves or tape. It's not qualified for that. In a liquid, you want to make sure you're wearing an enhanced level B suit. You want to make sure that you have a hood for head and neck protection, and thermal underwear should be worn because, as I spoke about earlier, liquid chlorine is going to be at a minus 29 degrees or less, so you're going to have potential for frostbite. This slide is probably one of the most important things for the first responders to remember: your emergency contact and resources. There are resources out there that are available to you when you're dealing with a chlorine emergency. Who are you going to contact? Call Chemtrec. Chemtrec will initiate the ChlorEP plan, and they'll get a ChlorEP sector team leader will be responding to you and making contact with you in a very short period of time. Also, Chemtrec can offer other valuable resources to you, such as an SDS sheet. So you can look at what you need to do in order to respond to a small leak, a fire, or an exposure. They also can tell you the manufacturer of the product and who the transporter was. Situation assessment can be significantly different when you're dealing with chlorine containers other than rail cars. They can pretty much happen anywhere. They could be on any road, highway, dirt road. They can be stored at a fixed facility, in a rural water treatment plant. It can be almost anywhere. So you want to make sure that you assess the situation and determine what your avenues are to dealing with that release. You also have different kits that are available depending on what container it is, whether it's a 1-ton container or a 150-pound cylinder. If you are dealing with a chlorine rail car, keep in mind that a loaded chlorine tank car is only about 80% liquid full. It has a 20% vapor head space to allow for expansion. The pressure in a loaded rail car is somewhere between 60 and 100 psig, depending on the temperature of the chlorine. The product temperature is going to vary in that range from 50 to 80 degrees Fahrenheit. If it's a residue car that's returning back to the manufacturer, it's going to have somewhere around 2,500 pounds of a mixture of chlorine vapor, liquid, and air. But that car is going to be pressurized somewhere between 150 and 275 psig. The reason that you have higher pressure in a residue car than you actually have on a loaded car is that most chlorine cars, when they're offloaded, they use a pad gas to push the liquid out of the car. So the remaining pressure is that pad gas in the car. In an emergency response to a chlorine event, one of your major focuses is going to be on containment. And most all the time, that containment issue is going to be dealing with the vapor. Also keep in mind when you approach a leaking chlorine cylinder, your first instinct often is to put water on the container. As we talked about earlier, that's probably one of the worst things you can do. I can tell you in all the years that I've been an emergency responder, I've never seen anything good done with water at a chlorine emergency. Remember that water and chlorine make hydrochloric acid, and they will increase the size of the leak and make the problem worse. Plus, as we talked about earlier, water on the vessel will raise the temperature of the chlorine. If you raise the temperature, you're going to raise the pressure, you're going to involve more vapor. It's also going to, the vaporization rate will significantly increase. I remember when we had an incident where there was a chlorine 150-pound cylinder that was leaking at a pool. The people responding to it thought it might be a good idea just to roll that cylinder into the pool because it would absorb into the water. Well, as we talked about earlier, the chlorine vapor will not absorb appreciably at all into water. So that didn't happen. It also added water to make the chlorine leak wet, which increased the size of the hole in the container, which increased the leak rate, along with the water reacting with the chlorine. It raised the temperature of the chlorine, which made it vaporize quicker. And in addition to that, you can't apply any of the Institute kits, such as the A kit, if your cylinder is laying at the bottom of the pool. Remember, first and foremost, when you're responding to a chemical emergency, your number one priority is to protect the public from harm. Protective actions should be initiated immediately after you've isolated the perimeter and you have your hazard control zones laid out and well communicated. Tactical options need to be reviewed, whether you're going to evacuate, whether you're going to shelter in place, or do some combination of the two. There's really no clear criteria of exactly how to manage that situation, and it's going to vary significantly depending on your particular situation. As far as evacuation and shelter in place, you want to remember those two options are not mutually exclusive. It's not uncommon at all at the same event to actually implement both procedures. And to give you an example where that may make sense, if you had a chlorine release that occurred in an area that had a valley, well, for the folks who live on the higher elevations that would be up and above where most of the chlorine vapor is going to travel, evacuation may very well be a viable option. Whereas for folks that would maybe be living down in the lower elevations where the chlorine vapor is going to tend to migrate, shelter in place may be their only viable option. One of the things that we have to consider today that we didn't talk about as little as 10 years ago is security concerns at a chlorine incident. It used to be whenever we approached a chlorine incident, we assumed that it was an accident. Now, we can't make that assumption today. So remember, if you're dealing with a chlorine emergency that looks suspicious, you have to be concerned about evidence preservation, because what you're actually dealing with now is a crime scene. You want to make sure that you look around and look for any kind of suspicious surroundings or behavior when you arrive on site. People ask, okay, I want to look for something that looks suspicious. Well, what is that? Well, it's just something out of place. One of the first places that I would look is that chlorine tank cars are shipped with very heavy stainless steel security seals on the protective housing. If you arrive at the incident and that seal is missing, that's suspicious. Start looking around and paying greater attention to the particular situation you're dealing with. You want to make sure you've made prior notification of where you're in and when you're going in so that you're communicating where you're located at. You're not going to make an entry into an incident site that looks suspicious until you've secured the perimeter. You never want to send a team into an area that looks suspicious without having law enforcement involved. You want to make sure you have all your zones established, you have that perimeter security in place, and you've notified the local hospitals in case you come across victims. As I said before, you're not alone when you're dealing with chlorine emergencies. There's a lot of additional information and a lot of resources available on the Chlorine Institute website, which is located at www.chlorineinstitute.org. There's a tremendous number of pamphlets on there dealing with chlorine and mission chemicals, along with DVDs and helpful videos on how to install emergency kits. Most all of these pamphlets are available free by download. In addition, the TransCare website is an excellent place to go when you're looking for local training and expertise in your area, which is www.transcare.com.
Module 2 explores tank car and rail safety. Several industry experts present this module. 1 is from the railroad, and 3 are from our primary emergency response contractors for chlorine incidents. They are Clay Reed. Clay is the Hazardous Materials Field Operations and Emergency Response Manager at BNSF Railway. Clay has served on several Chlorine Institute task groups. Terry Rockwell. Terry is the Vice President of Specialized Response Solutions. Terry is a longtime Chlorine Institute participant, emergency response trainer, and responder. Tracy Clark. Tracy is a managing partner with United Professional Services. Like Terry, Tracy is a longtime contributor to the Institute's emergency response programs. And Alan Higginbotham. Hig, as he is known, is the operations manager for United States Environmental Services and has extensive experience as a hazmat responder. Hig, Terry, and Tracy make a great team, and they are just the kind of people you want to call on in a hazardous materials emergency.
Okay, my name's Alan Higginbotham with the Chlorine Institute. Today we're going to talk about a 90-ton chlorine tank car. It's the most heavy-duty built tank car running up and down the rail, used for chlorine transporting in and out of facilities. We're going to kind of look at the construction of this to help you identify these tank cars in the event of emergencies or derailments. When you look at this, it's a jacketed tank car. And why is that important? When you're doing a damage assessment, the damage you see on this outer shell might not necessarily be damage to the inside tank. This tank is made of 3/4 inch thick steel, and then you have an outer jacket wrapped around 4 inches of insulation between. How we know that? Most of your tank cars, on the ends, you have cylinders that are all welded together, then the heads are welded on the end, and they're usually rounded. When you see these sharp ends right here, that's a good notation that this is a jacketed car. Also here on the bolster here, actually the cradle that this tank car sits in, you don't see where it's welded to the tank itself. You'll see a rain bonnet over it right there, another indication. And again, that's important to know when you're doing your damage assessment. You're going out there and find out what's wrong with this car, because you could just have a dent or a gouge, and it could just be the outer shell itself and not damage to the tank. When we look at this and getting our reference points on this tank car, we have an A end, a B end of a car. The B end is where our brake is right here. And there won't be a brake on the other side of the car. So everything will be referenced from the B end of the car with a right side and a left side. So when you do your damage assessment and you're calling back to your command post, and they're all on the same page referencing where your damage is and what you're seeing. Tank cars are attached to each other through couplers. Hazmat tank cars are used double shelf couplers. So you'll see that they're connected so in the event of a derail, these couplers don't come apart and gouge into the other tank and damage the tank itself. Because you'll notice on this tank car there's no fittings or valves on the bottom of this car. All your valves and fittings are going to be on top of the car inside of protective housing. Here we have the A end of the car. You'll notice the absence of the brake wheel, which distinguishes this as the A side of our car for our reference point. Also on the sides of the car you'll see some stenciling and marking, and Tracy's going to explain what those mean to this car.
This number you see right here is the identification number for this particular tank car. This number was applied to this car when it was built, and it will stay with it until the last of time. And in case of an emergency, this number could be called in and they could find out who the shipper is and the product that is in the car. Looking at the tank car on the side, the identification number will always be on the left side and on each end of the car. So it's very important to know where that's at. Below it is the load limit in poundage of product, 180,000 pounds, usually about 170,000 pounds of product of what they will put in it, as well as the light limit of the car. As we proceed down the car, as you notice, it's got the markings of the insulation, 2 inches of glass wool blanket over 2 inches ceramic fiber. Again, that's 4 inches behind this jacket, so you have at least 4 inches of space between the outer shell or the jacket and the inside tank. We've also got the identification marking of the car on the end. And on the end of it, you see the capacity in gallons and in liters. And as you will know, 17,332 gallons. Usually it's about 14,900 gallons. They leave some outage inside the car. That will be on the other end of the car, but they are always on the end. You can see the capacity in gallons and liters. If you will notice here, this is the placard for this particular commodity, which is chlorine 1017. It's a class 2, which is a compressed gas liquid, and it will be on all 4 of the sides per DOT specifications. As we proceed down the car, if you will notice right here, this is the emergency number to Chemtrec, 800-424-9300. With this number, you could report if this car was in an accident or leaking or what have you. You could call that number, give the identification number that we talked about earlier, and again, they could contact the shipper and get emergency personnel on their way. This brings us to the right side of the car. And if you'll notice, it has the inhalation hazard, chlorine. You will see that on Chlorine Cars stencil. You will see a built date, which looks like an old-fashioned type chalkboard, and it will have the built date of the car when it was built. Again, you will see a placard on the side, all 4 sides of the car. Okay, we're looking at the car specification number. This is a DOT, which that's a governing body of this tank car, and it's a 105J500W, and the 105 designates the type of car that it is, which is used in chlorine, J for jacketed, and then 500 is the working pressure. Now, after 2012 is the next generation car, and it'd be a DOT 105J600 or 600 pound working pressure. That working pressure is what that car could be working at. However, there is a burst pressure of that is 5 times more than that. So that's a pretty good safety factor. When you come underneath that to the qualification outline, it says when the tank was qualified last or tested, the tank thickness test to make sure that there's no erosion on the steel on the inside tank. And if you notice the service equipment, and if you notice the PRD, that's the pressure relief device, it is set at 375 PSI. So if you'll notice, that is below the tank working pressure of 500 pounds that you see on the DOT number at the top. So there's quite a lot of safety factors built into these cars. We are now at the B end of the car. As you can see, the brake wheel. And once again, the identification marking is at the top. It's on the end. We talked about it being on the other end, on the A end, and on the left of the car on each side. And as you will notice, once again, it has the capacity in gallons and liters on this end of the car. Again, the 1017 placard, it will be on every side of the car. Now, Terry will go over the protective housing on the top and the valving and how they work.
Hi, my name's Terry Rockwell. I'm with the Chlorine Institute. We're here today. We've already looked at some of the construction on the car and the stenciling and marketing. And we're going to go up top and we're going to take a look at the protective housing. Whenever mounting the car, we want to make sure that we use 3 points of contact and your chin is not one of them. Now that we're on top of the car, we want to talk about the protective housing. As responders, whenever we get on top of the car, we want to make sure the seal is intact. The seal is always placed on the car after the car has been loaded. We want to make sure that that seal has been intact, is still intact, and that we have not had anyone cutting the car prior to us mounting on the car. The liquid valves running lengthways will have an induction pipe located underneath the pressure plate, and right under the angle valve itself, on the pressure plate attached to the bottom of the pressure plate will be what we call an excess flow valve. Excess flow valves on most tank cars are 15,000 pound per hour excess flow valves. On the bottom of the excess flow valve is a pipe, induction pipe that's connected to it that will travel down inside the car within 2 inches of the floor of the car for liquid removal. The vapor valves will not have induction pipes or excess flow valves on the tank car. Pressure relief device. Again, pressure relief device is set at 375 PSI. When coming up on top of the tank car to take pressures off the tank car, we usually take them off of the vapor side so that we get a pressure reading before trying to fix something or apply the kit. The next generation protective housing that you'll see that was built after 2012, which is on some of the cars that are getting more prevalent nowadays, you'll see that it have 3 angle valves with the safety relief device offset and not in the center of the protective housing itself. Prior to releasing the car or shipping the car back down the rail, we want to make sure that these things are intact. All 4 plugs are located inside the valves and they're secure and they're tight. We want to also make sure that the tags are still on the valves if we need those tags, paper tags on there. Also, very important that we take the returning seal, RA seal, and place it on the car itself once we have closed the lid, replaced the pin for the lid, and then we want to reseal the car and then document or record the number on that seal, and then your car can be released.
U.S. railroads transported over 1.7 million shipments of hazardous materials last year, and 99.96% made it to destination without incident. Railroad is an extremely safe way to transport hazardous materials, and very few times do we experience problems in that supply chain. When accidents do occur, it's important to understand that you're not as a responder, you're not in it alone. The railroad has many different resources that we will send to the site to help you deal with any type of emergency response that you have on the railroad. Some of the things I want to cover in the objectives of this are to talk about some of the things you'll need to do, which is contacting the railroad, assessing the situation, and being able to engage the resources that are available to you. It's important when you're responding to a railroad incident that you call the railroad. And it's also important that you pre-plan before you have an accident in your jurisdiction or city to understand whose railroad might be running through your area. So when you have a call, it could come through 911. The railroad may or may not know that there's an incident occurring right there. So what you can do is you need to call the railroad, explain that you are responding to the incident, and then give them all the pertinent information about that incident, like where it is. How are they going to know where that incident is? You need to explain it to them. When you're responding to an incident, especially one that's at a crossing, it's important to look for the signs that are at that crossing. There's 2 different types of crossing that you'll see when you respond to an emergency at a crossing. One will be one that has automated arms that come down with the flashing lights that everybody's familiar with. Around those crossings, there will be a silver small building, and it's called a signal bungalow. And on that building, there will be information. And that information tells you whose railroad that is that's operating that crossing. It also has a 1-800 number, emergency response number. It has a DOT crossing number, and that crossing number is a serial number that's specifically assigned to that crossing. There's only one crossing that has that number in the United States. So what that does is when you call in, you can identify the crossing by that number, that serial number, and it gives the responding railroad or whose railroad it is exact information of where you are. It will also have it'll say M.P. and it'll have a number there. That's the milepost number. That number does not coincide with DOT highway or interstate markings. That is a sole milepost marking for the railroad, and that's what we use. So it's important, even if that track is adjacent to an interstate or a highway, they do not share milepost markers. So when you have an accident at a grade crossing, it's very important that you start looking for all these identifiers and you start trying to find this information. If it is a railroad crossing that does not have the automated arms that come down and the flashing lights, look for a blue sign on what we call the cross bucks, which is that X symbol that says railroad crossing, and that has all the pertinent information of the railroad. There again, it'll have the 1-800 number, it'll have your unique identifier, that DOT serial number, so to speak, and it'll have the milepost on it. So those are important features to find. You can call the railroad and then identify where you are. Also, if you have GPS, you can utilize your GPS to give more information about where you are. Think about most of the places that railroads operate are in rural communities, so a lot of times we're not in a town, all right? So then You can use that information to help identify where you are. It's important, and we'll say it again and again, it's some of the things to understand is you're not in an emergency alone. You have a lot of resources coming to you. It's also very important to stay in contact with the railroad. The railroad can help you in a lot of different ways. It's going to be providing notifications to other entities that need to understand about what's going on with this emergency. So they might be calling the federal agencies, state agencies, and all that, and letting them know how this incident's progressing or what's going on with the incident and any type of release that's suspected or has been confirmed. So that's very important that you call the railroad and let them know and start that interchange of information, because that's important and that'll help you throughout this emergency. Many of the railroads have geographical information systems, or GIS systems, and those systems are actual overlays that can be put on a map, and it'll actually show where we might have sensitive environmental receptors, water intakes for communities. It could have school, hospital locations, pipeline and underground utilities as well. So that's information as when you're talking to the emergency response center for whatever railroad you're working for, they can really help you, especially if you don't have that readily available. They can tell you of some of the things that you need to start being cognizant of as you're responding, like a water receptor or a sensitive environmental receptor. Railroads also contract with independent contractors and government agencies that can help you with plume dispersion modeling if there's a suspected or verified release of chlorine. What these guys can do is come in, and they have some very good computer programming methodologies and programs that can help use real-time meteorological information, and they can actually give you very good plume dispersion modeling to help you anticipate what this plume could look like or anticipate how this plume will progress through your community if that's the case. Some of the resources that the railroad will provide to an incident will be our engineering department, our mechanical department, and our transportation department. Also, we will supply or provide hazardous materials contractors, security, environmental contractors, and there again, industrial hygiene contractors. It's important to remember that when responding to a hazardous material incident on the railroad that you use all the resources that you have. When you're assessing the situation, it's important to do so from a distance, utilizing your binoculars, and see the conditions that you have. Do you have visible signs of a leak? And that's going to be vapors or smoke or liquid coming out of a car. So you want to visualize that from a safe distance first. And you want to try to find your train crew. Your train crew is going to have the most current paperwork for that train, the consist. And in that consist, you're going to find all your hazardous materials cars and in the proper order or sequence that they are in the train. So it's important to have all those items there together and help you do a good size up of an incident there. If you have a derailment, one of the easiest ways that you can start on a derailment are find the cars that you can identify that are in the upright position. Find those cars on the train list, and then you can work from there to help you figure out what part of the train has derailed. Some of our trains carry 100 cars, so trying to count cars from the locomotive to the rear of the car to the rear of the train can be very burdensome. So what you want to try to do is find the cars that are upright, go from there, and that'll give you a good spot on that consist to start working and trying to identify the cars that have actually been derailed. All right, so let's look at the shipping papers. Once you've obtained the shipping papers from the train crew, you can identify your hazardous materials cars in those shipping papers. Those cars are a sequence, and the cars will be either listed from the front of the train to the rear of the train or from the back of the train to the front of the train. If the cars are listed from the back of the train to the front of the train, it will be noted on the top of the consist. Okay, so it's important to understand which direction that you're looking. Now, that consist will tell you the hazardous materials cars, and they'll be identified by a box with asterisks around it, and it'll say hazmat or give you another type of indication that that is a hazardous materials car. And in there you'll find your quantities, your hazardous material, your packing group, your UN number that's associated with that, your shipper, and consignee. We'll look at this shipping entry. It's for a chlorine car that has 166,500 pounds of chlorine. You can see here that it shows the UN 1017 placard that would be on the side of the car. The class is 2.3, which is compressed gas, poison on there. And you can see that where the emergency response numbers. So what this does for you is when you're looking at that car, maybe it's either leaking or has been derailed, you can verify that information because you're going to look at your unique identifier number that's been talked about earlier today, the letters and the initials on the car, and then you're going to look for that placard to make sure that placard reads the same thing as the placard on this manifest, and you'll start looking at these different pieces of the puzzle to make sure that they're all making sense to you, that the car you're looking at is actually the car on the manifest that you're reading on the manifest. It's very important to understand that the car that you think that you're looking at is actually the car that's listed on the manifest, and you can have those the product be the right product, and you're not mistaking one car for another. The next entry or the next slide talks about or reads about a car that's got residue last contained. It's got the same information, but it's important to see that the residue last contained is on there. When these cars are residue last contained does not mean that they're empty. It means they have residue. So they can have 7% of what the load is left in them. So when we respond to those type of cars, it's very important to know that you're not dealing with an empty car. You do have a residual amount of product in those cars. At the back of the consist, we have emergency response information. This information is not an MSDS or a SDS. This information is information that you can read about each one of the hazmat shipments in the train, and it gives you some good general information what to go with. It'll give you visual clues. In the case of chlorine, it'll talk about that it's a greenish-yellow cloud. That will help you identify when you go to a response to start looking for that kind of material. It'll give you the weight of the product. It'll tell you if the vapors are heavier or lighter than air. So that'll help you position your equipment or know where to look with your air monitoring devices on where to start looking for that material. If that material is heavier, in the case of chlorine, than air, you'll want to look in those low-lying areas and start your response or start your air monitoring from those type of places. When we talk about damage assessment, I think it's very important for us to understand damage assessment. Damage assessment needs to be done by people that are trained to do damage assessment and have experience. Damage assessment, true damage assessment, cannot be done with a pair of binoculars from a distance. Damage assessment needs to be done up close and personal with that rail car. Responders need to have access to the site so they can do proper damage assessment, because doing damage assessment from a distance just doesn't work. So here again, you're not, as a responder, you're not in this deal alone. We have people that will be coming to the site to help you do damage assessment, and they've got a lot of experience, have been trained in damage assessment. When we look at damage assessment, we look at all kinds of different things that play into the equation for damage assessment. We look at when the car was built. We look at the type of car that we have, and we look at all other type of conditions like train speed and even geographical. The terrain that we're in. A derailment in a swamp can be a lot different than a derailment that is in a canyon and damage that's done to the car. So those type of things are some of the things that we look for. Now, when we see a car that maybe is not on its wheels, that has been derailed, we typically look at that car. These chlorine cars are very robust cars. They can take a lot of abuse and a lot of punishment and still stay together and not leak. So what we do when we come to a damage assessment, we might see a car that's laying on its side that's been derailed, and we might look at that much like the picture that's in this slide that shows just a herbicide or a pesticide bottle that's been knocked over in your garage, right? So I like to liken it to this, or to give this example. If you had a bottle of pesticide knocked over in your garage at your house, you would not evacuate your house on the basis that you think there could be something wrong. They're both robust containers. They're both holding their product inside, but they're just not in the position that we normally see them in, right? So a lot of times we can come in and we can upright these containers with their contents in them, and there's not a problem because they haven't leaked. If there's a leak, it changes things a little bit. It changes things if there's a leak, and then we have to do something different. But that's why we need to do a good up-close damage assessment to these containers to make sure that they're in good shape and to see just exactly what we're dealing with. This next slide shows damage assessment, and it shows, kind of gives you a good visual of the jacket damage. On the picture on the left will show the jacket has been torn back, and you can actually see the insulation. And this car, the tank itself, the part of this car that holds the commodity, the tank, could be in great condition, not anything wrong with it, but it has the jacket. And that can look kind of spectacular to some people that don't have a lot of experience, and it might look like there's some severe damage to this container, but there's not. It's just the outer jacket has been torn back and you can see the exposed insulation. That is not an indication of a leak. That just means that we need to take a closer look at that container to make sure that what condition that it really is in. In conclusion, I think it's important for us to take some things and kind of put them all together. One thing is understand whose railroad runs through your community or jurisdiction. 3 o'clock in the morning is not the time to try to understand or figure out whose railroad runs through your jurisdiction or community or which tracks you are on. All right, so do some pre-planning to figure that out. Understand how to contact the railroad. Look for those signs on the crossbucks or on the signal bungalow when you arrive, so you can give some good information on where you are. Utilize your GPS. Look for milepost markers. Give the railroad, the service interruption desk, or whoever you're talking to, that good information so they can quickly identify where you are and get resources to you. Understand that you need to get the paperwork from the train crew. That's one of the most vital pieces of equipment that you'll get. So find that train crew, or you can get it from the service interruption desk that you're calling at the railroad. So you can get that paperwork either faxed to you, emailed to you, or they can actually read it to you over the phone if you need to. So get those pieces of the puzzle together. Then you can start verifying what cars you have leaking. You'll do that with that train list, that manifest, and a pair of binoculars. So you want to look at what car that you have a problem with. Maybe it's a derailment, maybe it's just a leaking car. And you'll want to be able to look through the binoculars and tell the guy next to you, you know, this is the car I'm seeing, this is the initials, the numbers, here's the placard I'm seeing, here's the information that I see on the car, and you'll compare that with your train list, and that way you have that double check system to make sure that you're working or identifying the right car that's leaking. All right, then you need to understand the railroad's going to give you a lot of resources. We're going to have the re-railment crew. We're going to have different agents or different departments within the railroad responding. We're going to have hazmat contractors if we need to. Utilize all those guys and their experience for damage assessment, for just getting a general overall assessment of the situation and how bad this leak is or how bad this derailment is. Utilize those guys. The railroad needs to be involved in that incident command system. We need to be involved as far as the subject matter experts maybe, or in the operations department. We need to be in that incident command system because we can help you. We can help you make decisions. A lot of times for a career fireman, a derailment or responder, a derailment's a once-in-a-career kind of thing, right? So you need to utilize the people that have seen several derailments or been involved in the business for a long time to be able to help you utilize, to understand and get the resources that you need there and really help you understand the type of emergency that you have. Use the shippers. Use all these people that are available to you. So there's no reason to feel like you're an island unto yourself. You have a lot of resources there, and you just need to reach out and utilize those resources.
Our third training module on cylinders and ton containers and the use of emergency kits A and B is presented by Manny Correa and Mike Croak. Manny is the plant superintendent and emergency response team leader for Keeney Company. Manny is also the vice chairman of the Emergency Preparedness Issue Team at the Chlorine Institute. Manny is joined by Mike Croak, who serves as branch manager at JCI Jones Chemicals Incorporated. Mike also coordinates emergency response activities both for JCI Jones and as a part of the ChlorEP network.
Today, for Module 3, we're going to be discussing the cylinder, the chlorine cylinder, and also the ton container. And we're going to discuss with the A kit, that's for the cylinder, and the B kit, the emergency capping kit B, for the ton container. And throughout the segment, I'm going to focus on 3 major elements. And those 3 elements consist of the cylinder proper, okay, the characteristics of the cylinder. We'll get into specific details. Then we'll talk about the valve and its properties, okay? And around the valve, we'll pay a lot of attention to the typical leak points, because a lot of times the capping kit should be used as a last means of defense, because typically what we find is that the valve is just cracked open. And I'm going to demonstrate that throughout the segment. And lastly, if we do need to apply the kit, I'm going to demonstrate how to properly apply it. There's 3 types of cylinders. The 150-pound cylinder, as we see here today, is basically the most common. But there are also 100-pound cylinders, and they're slightly smaller. And then a third that's not as common, and that's a 20-pound cylinder, so a smaller cylinder. The 20-pound cylinders are mainly used in the pool industry. They're not as readily available, if you will, throughout the industry, except for the one stated. The 150-pound, however, is the one that's mainly used specifically for the water treatment facilities. And the type of cylinder, it's a carbon steel cylinder, okay? The DOT classification for the cylinder is either a 3A 480 or a 3AA 480, and all the information can be found on the neck ring. Okay, it's very important to know that. Color itself is not a good indication of the contents within the cylinder. Please never rely on the sole color as your last means of defense to determine or identify, is this really a chlorine cylinder or not? The one today obviously is a training cylinder, but there's blue cylinders, there's gray cylinders, there's red cylinders. It all depends on the actual supplier and what their preference may be. We'll talk about the weight. For a 150-pound cylinder, which is the tallest cylinder, an empty weight typically is between 90 and 100 pounds. So without 150 pounds of chlorine inside, it's a pretty heavy vessel in itself. Some of the other markings that you will find would be the test criteria for the cylinder. Once every 5 years, each cylinder has to go through a Department of Transportation or DOT's requalification. And within this, the cylinder is actually filled with water. That's one of the test methods. And it's charged with air up to about 800 pounds of pressure. And what you're really doing, you're testing the elasticity of the steel. That's very important. You want the steel to actually expand and contract, okay, which is critical. And once requalified, it receives a new test date, and all that data is found on the neck ring. Stenciling on the cylinder is very important as well. The supplier is mandated by the Department of Transportation and just good old common sense to identify what the contents of the cylinder is. And basically, the cylinder would be approximately 2-inch letters, and you would see inhalation hazard, you would see the words chlorine, you would also see the UN number, 1017, all stenciled on the body of the cylinder proper. Typically, there are 3 different types of cylinder bottoms. The first is a foot ring bottom, which we see here today, and that's basically a steel ring and it's tack welded to the bottom of the cylinder. The second most common is a double bottom, whereas it's a solid ring and it has a solid weld. And then the third is a flat bottom where it has no ring and it actually has a concaved bottom. Typically with the double bottom foot rings and the split foot ring, there have been times where with re-welding of the cylinder, it introduced a potential leak point. So not always will the leak source be from the top of the cylinder, okay? And there's really nothing in the emergency capping kit that we're going to discuss later on in this segment that's going to stop or contain the leak coming from the bottom of the cylinder. You would need another device, which is a salvage vessel, or you would have to do a field transfer, and we'll discuss that later on. The final comment that I'm going to make and emphasize in regards to the characteristics of the cylinders is the seamless construction. We already discussed that they're made from carbon steel, but there are no welds. So it is a seamless construction cylinder. The typical chlorine valve on the cylinder, there's really one main difference between a cylinder valve and a ton container valve, and that's basically the fuse plug. A ton container valve looks identical with the exception of the fuse plug, and we'll discuss the fuse plug a little later on. It operates in the same fashion as the ton container valve, and the typical leak points that we had said we were going to discuss in detail. If a leak, common point is at the packing nut. If you develop a leak at the packing nut, it's telling you that the valve should still be in the open position. It may not be fully open, as it only takes one full turn to open or close this valve. But if it's leaking from the packing nut, chances are that the valve is still open. And a quick remedy is to close the valve or adjust the packing by tightening the packing just enough to actually stop the leak. If you could actually close the valve completely, close it. Another leak point is through the valve outlet cap. Again, with the 200 wrench, we could tighten the capping and see if that works. With the valve cap on snug and tight, we could open and close the valve stem to try to dislodge any material that may be sitting on the valve seat, and then we could just check it again with aqueous ammonia. It's very important throughout these presentations, and anytime you're dealing with chlorine, that you're only using aqueous ammonia to test for leaks, not the liquid. Another leak point is at the threads from the fusible plug itself. Okay? It could be the fusible plug. The fusible plug is designed to melt. That's its purpose. Unlike a ton container, where the ton container has 6 of these fusible plugs on the vessel itself. The cylinder doesn't have that. We already discussed it. So this is the only source of a pressure relief device for the cylinder. Now, the way it works, unlike other valves, pressure relief devices that are spring-loaded and operate on pressure alone, this doesn't work that way. The way it operates is by temperature. So the scenario, the example that I'll give you, if the cylinder happens to be near heat, a heat source such as a fire, the fusible plug will melt between 158 to 165 degrees Fahrenheit, thus releasing the pressure, because we already know that as heat builds up, pressure builds up inside the cylinder, and instead of having a catastrophic failure, the link will melt and it will release the pressure. Now that leads into the capacity of a full cylinder. A full cylinder is considered to be 80% full. Okay, that's what we consider to be full. The other 20% space is left there intentionally, if you will, by design for expansion. As the temperature increases or decreases, so is the liquid that's inside the vessel. Now, typically for a 150-pound cylinder, if we convert that to gallons, that 150 pounds of liquid chlorine is roughly about 12 gallons of elemental or liquid chlorine. Finally, the other leak point on the valve would be at the threads of the valve and the cylinder neck. I do not recommend that we retorque or tighten if we find that the leak source is at the threads, that we retorque the valve into the cylinder. And the reason that I don't recommend that, there are tools in the kit to do that, but it's a more specialized event. And specifically, the additional training that a person would have would be to make sure that he checks the condition of those threads. And we just don't take it for granted that if the leak point is here, that the threads, both on the valve and the cylinder, are in really good condition, because the last thing anybody wants to do is tighten the valve further into the cylinder and then end up with the valve in one hand, the cylinder in the other hand, and say, I'd like to demonstrate how to actually open and close the cylinder valve, what it actually looks like. A lot of times we'll be responding to an incident and the valve is leaking. And quite often a capping kit or device 1 is just applied. So I'd like to demonstrate what it actually looks like. And the industry uses what's known to us as a 200 wrench. It's a wrench that is inside the A kit, and it's actually used to fill these cylinders. One full turn and the valve is open. One full turn, the valve is closed. One of the most important things to do when you find yourself with a leaking cylinder is to make sure that the cylinder is rotated so that the leak is in a gaseous state versus trying to handle a liquid leak. So an example would be if the cylinder is lying on the ground and the leak is from the valve area, you want to first lift the cylinder so it's in a vertical position. Just by doing that alone, you put yourself where you're dealing with a vapor leak or a gas leak versus a liquid leak. And as we know, the expansion ratio of chlorine is 460 to 1. So you just eliminated 459 other problems that you might have. So that's an important note. When you do have to apply device 1, the very first thing you want to do is get your base and just stretch the chains out. It just makes it easier. And then you would rotate the cylinder place it as square as possible. What you want to do with the hood assembly is actually make sure that the vent valve is in an open position. So to double check, you would just use your 200 wrench and you would just make sure it's open. You then want to apply the gasket. The important note with the gasket is to make sure that you do a visual inspection and just look for defects. You want to look for chafing, some cracks, and just the general condition, because this is what's actually going to seal the leak. Try to keep the vent valve opposite where your work area is. It's important to keep the chains as straight as possible. And one of the tricks is to count the excess links so you keep them all the same as you go around through all three. You would twist the center bolt only. And this is going to take up the slack of the chain. If you try to work with all 4 bolts, you'll never get it centered. So the center bolt already did its job. So now I'm going to finish the compression using the remaining 3. As you notice, the 3 are tight, but the center one is loose. That's okay. You would then close your vent valve. At this point, you want to tighten the bolts just enough to stop the leak. you do not want to over tighten the bolts, because there's enough torque to where you can cut the gasket, and then you would have to start all over again. Okay? So we would wait at this point, we would wait about 5 to 10 minutes, and then we would go back and check using aqueous ammonia to make sure that the leak is contained. If there's any leak present, the cylinder cannot be transported from where it currently is. Okay? It's not, you cannot legally transport this cylinder if there's any leak present. Okay? If there is a leak, you would go back and you could readjust or retorque those bolts. Wait a few moments, and then check again. You also check the outlet of the vent valve, making sure that it is not leaking as well. And you would install a valve outlet cap, making sure that there is a gasket inside the cap. And that's the application of device 1. When you find yourself in a situation where the fusible metal has melted out and you need to contain that, device 1 can be applied, but there's also a different option. You can use part number 2, and the kit has gaskets, and these gaskets are actually longer from previous versions, which actually helps the application, and I'm going to demonstrate that. You would slide the gasket, and just a note, if the valve still has the outlet cap installed, you do not need to remove that in order to apply part number 2. It'll still fit. And with the use of the 200 wrench, you would tighten that, and then you would wait a little bit, and then you would check with aqueous ammonia. The kit also contains a device or a part called A9, and commonly referred to in the industry as a hose barb. And the intention of the hose barb is, in the event that you need to scrub, if your only option, for whatever reason, is to exhaust either the pressure that may be on device 1's hood or the valve itself, the kit has the components to do so. It has a gasket, and you would just insert that like such. A hose could then be connected or inserted into the end, and it would typically go into an alkali solution, so a weak caustic or some kind of bicarbonate solution. In the event that the valve stem or the valve itself actually blows out of the cylinder, very rare, but this kit does contain components to correct that. So part A3 would be used if the valve stem blows out and the valve body remains intact, and you would just insert it and you would tap it using a hammer. And if the valve itself is removed for some reason from the cylinder, there's a part A4, and it would serve the same purpose. Utilizing the hammer that's within the kit itself, you would just tap it down, okay, and it would replace the valve. Next, we're going to discuss sidewall leaks. And sidewall leaks do happen, but what's important to remember about a sidewall leak is that there is a device number 8, within the A kit that will contain the leak, but it's important to note that the amount of pressure that's going to be applied on device 8 is, again, that golden rule of thumb. You're only going to apply enough pressure to stop the leak. Because if there is a sidewall leak, chances are the actual cylinder wall may be compromised. And the last thing we want to do is collapse the wall and introduce a bigger leak. The first thing that we would do is we would lie the cylinder down, and we would make sure that the hole would be on the vertical position. Utilizing the tools that are within the kit itself, I'm utilizing the base of device 1 to help prop the cylinder, secure it in place. I'm going to utilize the other component of device 1 and just shim it. It makes it easier for me to slide the chain underneath the cylinder. The leak is at the 12 o'clock position. There's a gasket. It's very important to also note that the gaskets that are used for chlorine emergencies are made out of Viton. It's very important that the material of construction is Viton. That's what's within the A kit itself. SO2, some of the kits actually have EPDM gaskets, but they're gray in color. Viton is black, okay? Part 8D, which makes up device 8, has a contour shape to it. And it's very important to also note that you would apply that with the shape of the cylinder itself. It's easier to set this apparatus up just near or adjacent to the actual leak. It's harder if you try to assemble these components directly over the leak, because that pressure may blow out your gasket. It just makes life more complicated. Life's complicated enough. Now you would take up some of the slack, just make it slightly hand tight, because you still want to maneuver this over your leak point. Okay. By pinching the 4 corners, you can hold the gasket and device 8B together, and you would just slide it over the hole. And now you can make your final torque adjustment. Make it hand tight, utilizing the 200 wrench. And how tight do we make it? Just tight enough to stop the leak. Very important. You do not want to over tighten it, because there is a possibility of collapsing the cylinder wall. Earlier we had discussed the salvage vessel or recovery vessel, as it's known. And the recovery vessel is a particularly important piece of equipment when you have a situation involving a bottom leak. It's very easy to just slide the cylinder inside the vessel and close the doors, and the incident's basically it's been mitigated. You would then contact a supplier, and that vessel would be taken over to the supplier and the cylinder evacuated at that point.
One of the changes adopted this year is a new variation to the A kit. While you may be very familiar with the A kit of the older design, we do have a new design. The new design adopted by the Chlorine Institute looks just like this. Instead of having to put your top yoke on and your chains basically hook right here, making it very simple to operate. Basically, you hook all chains on there, and instead of having to line them all up together, basically they're all independent of each other, and you can tighten it to get a nice even seal. Basically, you hook the chains on, make sure you got a clean link. Once you have your chains hooked on there, you can independently adjust them. One of the big features is it goes up and down on the threaded rod to make it nice and tight. It works with your standard wrench. The benefits of this hood versus the old hood is it's lighter, it's easier to put on. It's basically your chains on the bottom and this hood piece. It's a two-piece versus the three-piece unit that you have right there. It goes on quicker, you have a smaller chain, it hooks on and goes straight up versus pulls up as that one does. It's lower profile, which makes it a lot easier to handle, and it's a good unit. Once you get it on nice and tight, you're going to close your valve, put on an outlet cap. One of the advantages of this new designed bottom piece, the chain assembly, is it is very low profile. You have about an inch high, which allows so you don't even need the ramp. You just basically can roll the container on. You also have adjustments that adjust so you can get it nice and tight in. One of the advantages to this chain is if you wanted to put it on a short cylinder, it will still work on the short cylinders, 100-pounders as well as the smaller containers than that. That is a big advantage to this new generation kit. Another change in the newer kit is the side patch. Historically, you put the square patch on there with a chain, over tightening the chain. When you have a pinhole in a cylinder, you could have the possibility of line corrosion. Line corrosion would be like bathtub ring if you were looking inside the container. When you're looking inside the container, you may see a pinhole. In this case, one of the big changes, instead of the chain, is using a strap. The strap will disperse your tightness over a bigger area than just the cylinder, than just the chain. One of the changes is the gasket design. It's about 3/8 thick, and you have a little cup in there. That little cup will allow you to place it over there and disperse some of the pressure. Simple hookup. And instead of having to use a wrench, you have a knurled knob where you can just turn it by hand. Basically, you turn it by hand and stabilize it with these two little stabilizing knobs. You're good to go. The advantages is the pressure. Instead of having a chain digging into the side of the container, you have a strap, the stabilization, and the fact you don't have to use any tools, you're just using your hands, are all big advantages in putting on this particular piece of apparatus.
It's important to note that during an actual emergency, it's very important that we utilize the buddy system, we work in pairs, and we use the proper personal protective equipment. In closing, with the A-kit and the chlorine cylinder, there were some important keynotes, some takeaways from the characteristics of the cylinder itself, from the potential leak points on the valve. Remember, the A-kit, you have the tools to contain a leak, but during your investigation, 90% of the times, you could probably stop the leak using the 200 wrench if you know what to look for. And then the application of the kit itself. But please always remember that help is a phone call away. Whether it's the supplier, and we discussed how to identify some of the markings or numbers on the cylinder itself, You could also call Chemtrek, and through Chemtrek, the Chlorine Institute and the ChlorRep network would be activated to assist you. So you're never really by yourself.
I'm going to talk to you today about the ton container, very common in the water and waste treatment industry, as well as the emergency bead capping kit, which is used in the case of a leak on a ton container itself. The ton container is about 6'10", well, about 82 inches long, 30 inches in diameter. It has two concave sides, one on this end, one on the back side. 3 fusible plugs on each side. Fusible plugs are designed to melt out in lieu of overpressurizing the container itself. 2 valves, top valve and a bottom valve. There's a little chime area right here which has a bunch of information on it, tare weights, test dates, that type of thing. A lot of people consider that the top of a ton, but in essence, as long as one ton valve is in the 12 o'clock position, one is in the 6 o'clock position, the bottom valve is always designed to deliver liquid chlorine. Top valve is always designed to deliver gaseous chlorine. Ton container has 2 induction tubes. Bottom tube is designed to deliver liquid. Top valve will deliver gaseous chlorine. A full ton container with 2,000 pounds of chlorine in it is about 80% full. While these come to a 1/2 inch to the top, you can see how it would deliver gas, and this would always deliver liquid. None of this is here, that's all just training stuff, but basically that's what the inside of a ton container looks like. In the chlorine industry, we call this a chlorine ton, but the Department of Transportation calls it a DOT 106A500. Point being, this can be used for multiple gases. You just can't look at it and assume it's a chlorine ton. The same container is used for bromines, used for sulfur dioxide, and a whole host of other gases. The important thing to remember is to look for your stencil, labels, bills of lading, those type of things. You can't just assume automatically that it's chlorine ton. There's also a protective bonnet that goes over here. That's not part of the container. It's actually removed. All it does is protects the valves from being hit. Typical leak points on a ton container could be the packing nut, could be a valve not totally turned off correctly. It could be a spinner where the valve just keeps turning in a circle and won't shut off. Could be a leak in the back threads where it's threaded in the container. On a fuse plug, you may have the lead melted out, or you may have a leak in the back threads where it threads in the container. On a very rare occasion, you may find a side leak in the side of a ton container itself. All those leak points can be addressed with the emergency BCAT. On the ton container, there are 6 fuse plugs, 3 on one side, 3 on the other. Being it's 80% full, no matter how you rotate the container, they are designed that one fuse plug will always be in the gas phase. Okay? Obviously, if you have a leak, you want to rotate it to the gas phase so that you're dealing with gaseous chlorine versus liquid chlorine. Liquid chlorine expands 460 times its own rate. In addition to that, liquid chlorine is about 29.6 degrees below zero, so it's pretty cold. So you want to deal with the gas, which is a whole lot easier than dealing with the liquid. The fuse plugs itself melt at 158 to 165 degrees Fahrenheit. It's actually etched right into the fuse plug itself. Really makes no difference. If you remember 158 degrees, you'll always be good to go. Couple things about it. If the lead is just melted out, now this lead in here, as you can see, it's about a 3/8 on this side. The back side is 1/2 inch, so it is tapered. The lead is tapered. It will not fall out. It's going to have to melt out and be pushed out. It can melt from direct heat, but the design of it is to, if the container heats up, the container. As pressure builds, heat builds pressure, pressure melts the lead, lead comes out, and thus so does the chlorine. Unlike on a rail car, this fusible plug does not reseat. Once the lead's melted out, you have chlorine coming out. When you put your kit away as a responder, you want to put everything away correctly in your B kit. When you put your B kit, this is how you want to have it, just like this. Okay? Now they have these little round gaskets that come in every kit. You can simply put this on there, slide this right over the top, tighten it, and stop the leak. That quick, that easy. However, trying to hold this little thing when you're wearing a pair of rubber gloves is not the easiest thing in the world. So they made this little rectangular one, which looks like a stick of gum. We call it a stick of gum because it's easy to remember. You can hold this to the side, slap it on, tighten it up, and that quick you've stopped your chlorine leak. If it starts to leak a little bit more, you can always tighten it a little bit more, or you can now put the hood on it just for extra safety. If it's not flat and you have to put this hood on, it's pretty simple. Here again, you just slide it over the top, tighten it, store it with your gasket on. It's easier to take the gasket off than it is to put it on. Okay, there are two different size washers in these little boxes. One won't fit and one will fit. Okay? This is why you want to store it on your kit, so when you pull it out, you have the correct one right in your hand. Do a quick visual on it, make sure there's no cracks, any distortion. Put it on there. You can tighten it up, okay? Now, one thing you want to always remember, when you put this kit on, this kit's actually pulling on that fuse plug. So before you put that on, what you want to do is take your wrench and just make sure it's tight. You don't want to have a loose fuse plug, put that thing on, tighten it up, and have it pull the fuse plug right out. So you want to take your wrench, make sure it's tight. Okay? If it's tight, you can use this wrench, or you can use the socket. Socket with a breaker bar, righty-tighty, lefty-loosey. Put it in. Industry standard will be for 3 to 8 threads showing on a 3/4 inch fuse plug. That is so you can tighten it up and still get this thing on. Any kit you're going to put on there, you're going to find when you put it on, stopping 18 psi of chlorine and having it hold at 80 psi are two different things. One way to look for that is look for your auto refrigeration line. If chlorine has been leaking for even a short period of time, you'll start to see a frost level on there. What that frost level is auto refrigeration. In addition to telling you as a responder that when you see that frost line, you know it's lower pressure, it also tells you the level that's in the container, so you have an idea of how much is in there. If your fuse plug came right out, you have two options. You can take a drift pin, slide it in there with a big hammer, pound it in there. Problem being, this is steel, and so is the ton head. Steel on steel is not the best gasket in the world. However, what's your alternative? Your only other alternative is to actually take that fuse plug and try and thread it back in. So, drift pin is a last resort. If you can screw it back in, you're probably better off trying to screw it back in, because once you smash the threads up, you're not going to do anything. Okay? Next piece I'm going to talk about is the actual side patch. Finding a hole in a side of a cylinder, that's not totally uncommon, but finding a hole in the side of a ton It's kind of like finding gold in your backyard. You're not going to find it very often, and if you do, you better pay a lot of attention to it. In the kit, there is a device, the 9B patch. You're going to rotate the container to the top. You get your hole on the top. Now, before you go putting your side patch on, what you want to do is check your metal. Make sure you got some decent metal there. The last thing you want to do is take a pinhole, over tighten this thing, and turn it into a 3x3 hole. So you want to make sure you got some halfway decent metal. If you have paint buildup, you can take your paint scraper, which is in your kit, and scrape down the excess paint. It's got about an 1/8 inch thick gasket, so you know it's pretty easy to put it on, and paint buildup's not going to have a whole lot of effect on it. But if it is, you might as well just scrape it off a little bit. If you look at this patch, it has a curve to it. Now on the cylinder one, you can see it pretty prominent. On the ton one, it's not so easy to see. If you put it on nice and flat, it's not going to move. If you put it on cockeyed, it's going to wobble. You're not going to get anything out. You're not going to get nothing to tighten. On your kit itself, what I do is take and draw 2 arrows with a black Sharpie. The 2 arrows give you your lineup point, so when you put it on flat, it lines up with the chain, and you don't know, and you know you got it on right. Seems like pretty simple type of thing, but I've seen more than one patch put on wrong because the guy's wearing an air pack in a suit and just can't tell. So draw your 2 little arrows to the side. You'll never forget that. What you want to do is put it away with about 1 inch showing, so it's nice and flat, just like that. Center it over the top. Put the chain on. When you hook your chain on, you want to have clean links. What you don't ever want to do is hook it on like this, where you got a link caught in a link. Because what happens as soon as you get it nice and tight, being a chain, as soon as it moves, it's going to come loose again. So get a nice clean link. Another item for your kit is to put a little bungee cord in there, so when you put it across, you have your bungee cord holds it, so when you take your hands off it, everything doesn't fall on the ground. You're going to take your hole, you're going to put a little bit of tension on it, and then you're just going to maneuver it in place, just like we did on the A kit, and tighten it up. Once you got it nice and tight, what you want to do is take your wrench, smack your chain a little bit, and then tighten it some more, because being a chain, it's going to come loose. Now you're going to tighten it till one of 2 things happen. Either it stops leaking, or you're starting to compress the metal there. If you get that far, you're going to want to stop. Okay, and we'll deal with that at the end. But otherwise, wait 15-20 minutes, let it build up pressure, and tighten it again just a little bit. Then you start doing just little quarter turns. Okay, I'm going to demonstrate how the actual valve operates. Unlike a water faucet, it doesn't just open and close very easy. Okay, usually on a ton container, you're going to put your wrench on there. The first thing you're going to do is make sure your packing nut is snug. If it's real loose, when you open that valve, chlorine's going to come out. So you want to have it, make sure it's fairly snug. Now, some companies will torque it down to 50 foot-pounds. Some will just put it snug. The difference being, if you're using Teflon packing, you're probably going to be at 50 foot-pounds, the packing nut. If you're using Garlock packing, it can just be hand tight and then snug. Put your wrench on there, and then you're going to smack it on. Open it 1 complete turn, and that's how you open the valve. To close it, you go 1 complete turn, and then smack it closed. It does not just open and close very soft. You've got to smack it both ways. The valve will open about 1.5 to 2 turns. However, once the valve is rotated 1 complete turn, that's the maximum delivery of chlorine you're going to get out of it. So opening it any farther than that really is worthless. AWWA will tell operators open it 1 complete turn unless their plants tell them quarter turns. You'll have a lot of plants quarter turn, quarter turn. So you as a responder, you go in there and find a valve all the way open, that's kind of odd. Probably the easiest way to stop a leak for a valve that won't shut off is just put an outlet cap on. Make sure you got a gasket in there. If you don't have a gasket in there, there are extra gaskets in your kit. Slide it in there. Put it on and tighten it. I mean, that's a whole lot easier than putting on that big strong back and all that type of thing. This thing does more than protect the valve threads. It's designed to protect the valve threads, but it's also an emergency device in itself. If you have a leak through a pack-in, just tighten it down. Now, it's pretty easy. Just tighten it down. If you have leak in the back threads, you have what they call a crow's foot wrench. It's a crow's foot wrench. It slides on the valve. Take your breaker bar, righty-tighty, lefty-loosey. Everything on the container is righty-tighty, lefty-loosey. And you can just tighten it, okay? However, keep in mind, containers are filled at a fill-in location, then they're sent out to a location, and they're typically sitting at least 24 hours before they're hooked up. The chances of it just automatically starting leaking for a container sitting that are pretty slim. Typically, when you have a leak on a ton container, it's either during the hookup or the unhook. That's where most of your leaks occur. Or they've hooked it up and didn't hook it up correctly. It doesn't just start leaking for no design reason all of a sudden. That's pretty rare. And if that does occur, that is something to keep in mind. That should be a big red flag. Any container that just started leaking when it's sitting there is something that you want to put a gauge on and check the pressure in there, make sure it is not overfilled. Okay? We got 20% vapor space, but an overfilled container can build up a lot of pressure to the point where it can actually expand out the ends of a ton. So a container that's not hooked up and just sitting, you always want to check pressure on. If your stem should come out, you have a drift pin. Stick it in there, take your big hammer. You got steel on brass, it's going to seal pretty well. If your valve blows out or comes out, you can take your drift pin, but keep in mind you got them couplings welded right behind there in the back. Chances are you're not going to be able to pop it in there and stop the leak. So just keep in mind this is probably not your first choice. If you have a leak in the back of your ton, or you just can't get the valve to stop, or the valve just keeps turning in a circle and is a spinner, you may end up having to just put the strong back and the hood over it. It's a pretty simple piece. There are multiple gaskets with it. You have your cup gasket, which goes right on here. You have a flat gasket, just like this, nice and flat. And then you also have a gasket that has a little cut, a little scallop cut in there, okay? As a responder, the first thing you're going to want to do after you've done all your basics, try and turn the valve off, all that type of stuff, is you want to take your fingers and run it in here and see if there is a ridge. Some tons have a ridge, some tons don't. It's very important that you check that. If it has a ridge, you're going to have to use the scallop gasket. You can't stop it with the other gaskets. So when you store it, you want to store it with the gasket on. You want to make sure your valve is open or rotated, okay? You want to make sure your outlet cap's on hand tight. And of course, in this case, we're just going to take the gasket off because it's easier to take the gasket off than it is to try and put it on when you're wearing an air pack and 2 pair of rubber gloves and a suit. Now this little flat gasket is just a plain old flat gasket. That's flat. If there is no ridge, you put it on, it's a piece of cake, goes on with no problem. When you put this away, you want to have it right on the first thread, just like I have it right here. You want to have these flush right here. You want to have these hand tight, back off 1/4 turn. The object of it will be to line it up just like this. Okay? Being all these tons are a little bit different, sometimes you're going to have to go higher, sometimes you're going to have to go deeper, but you're never going to have to go lower. Okay? So at the very bottom, you know you're going to line up. The reason you back off a 1/4 turn is if I have to go all the way to the top, you can see I can tighten that with my bare hand and it's not going anywhere. Okay? That's just what my hands. 1/4 turn. Valve's going to be open. When you set up your kit, of course, you can have your valve pointing straight up, which you got chlorine coming in your face, or you can point it straight down where it's out of your way, or you can point it straight out. Problem with straight out is if you have to put a yoke and adapter on it to bleed it off, you're not going to be able to get it on there. So you want to take good care on which way. Most people are right-handed. A right-handed person is going to be on this side. So sometimes you may want to rotate that thing down or just pre-plan it all the way out. Now when you put this little scallop gasket on there, you've got to line it up exactly on the scallop. Okay? If you have it cockeyed, it's not going to work. Now you looking at it, you can't tell if it's on right or not, can you? No. So take yourself a Sharpie, draw 2 little arrows right here. Gold, silver Sharpie, white Sharpie. The 2 little arrows point straight down at the valve below it. If they point straight down, you know you've got it lined up right. Make it very easy on yourself. When you put this kit on, you figure if you got black all the way around, you got a good seal. However, if I get up around here, which typically happens if the guy running this thing doesn't know what he's doing, it has that tendency to start falling like that. Okay? And when it starts falling like that, you can stick your finger in the bottom and you end up with a leak. So while you're drawing your 2 little arrows on there, center it up and draw yourselves some lineup lines. So when I put this thing on there, he has something he can look right at to see if it's dropped or not. Okay? You want to just hold that. Now my job's going to be to stick this thing in here and look to the side. As soon as I look to the side, I'm going to have to decide whether I need to leave it like it is or raise it up. I like to just put it on my knee, raise it up where I need to, and tighten. Okay? These chime, there are 2 types of chimes. There's a chime where it's nice and flat, just like it is here, but sometimes you'll see a distinct ridge in there. When you see that ridge, you want to make sure you line up your kit on the same side of the ridge. If you're too deep, one side's deep and the other side isn't, once you start to tighten, the thing starts pulling out and it'll actually drop. And while it may only be 1/8 of an inch or 1/16 of an inch, your kit will come loose. So you want to concentrate on that. Slide it in there. I can see I got to come up. Straight to the top. Push up. See where my finger can fit in there? I just pushed it up and tightened it. Tighten straight in. Now, thumb rule is when he can shake it and it ain't coming loose, we're tight. Right? At this point, I'm going to go another half turn, and I'm going to shut my valve off. I'm going to shut my valve off. I'm going to let it build up a little bit of pressure, 10-15 minutes. I'm going to take my wrench, smack it a little bit, and tighten it again. At that point, I know I'm good to go. Then I can go back and readjust all these little adjustments and tighten everything nice and tight. But to stop the leak, it can be that quick. Line up on the side, tighten, push to the top, tighten. As soon as you tighten straight in, it locks everything together. As you can see, these ends are round. They're round for two reasons. One, so you don't cut your gloves, but they are round specifically for the container. You may encounter a ton container where it won't fit in there. You can't get it in. Not very common, but there are tons out there like that. That's round so that you can do this. Take out your top bolt, loosen your bottom bolt so you can turn it, slide it in, and then lock it in. Okay? I mean, put your kit on the exact same way. But you may encounter that where it will not fit. Well, to sum it up, that's the B kit. It's a ton container. Important things to remember is you always work in pairs. You've got to have PPE. You're going to be dealing with a lot of sweating if it's auto-refrigerated. You're going to be dealing with cold. You're going to be dealing with slippery things. Those are all real-life things putting on the B kit. With that said, you've got to practice putting it on. You can't put it on once a year and expect to be able to put it on. Fortunately, as responders, you probably don't have to put it on, which is a good thing. It says a lot about the industry. But when you do, you need to be ready. You need to practice PPE. Take your time. Put it on once. Put it on right, correctly, tight. When you put it on, always wait 10-15 minutes and check it again in case you have to retighten it. Don't over tighten. Snug, you tighten till it stops leaking, but don't over tighten it. I'm going to talk about the new redesigned B kit. This is fairly new. There's several features on it as opposed to the old kit. Number one, this thing is 8 pounds lighter than the older B kit. This device can be used on both the valve and fuse plug. It is spring loaded. This middle feature will adjust up and down depending which valve you're dealing with. In addition to that, it will tilt 10 degrees to put on a fuse plug by simply turning it in. This strong back goes on very similar to the old kit, except it is spring loaded and will go on much easier. First thing you're going to do is put your hood on like you normally would. You need to make sure this bolt is all the way to the back so you can't turn it anymore. Set it in place, line it up so that the center of this is on the center of that. Push down and lock it in. At that point, you can bring this down till it's approximately level. Just push forward slightly. Once you get it about targeted where you want to go, turn this knob. By turning this knob, you are basically disengaging the springs.
That's obnoxious loud noise.
Once you've disengaged the springs, you just tighten straight in. Go ahead and when he can't move that up and down, you're tight. Take your 200 wrench and shut your valve off. Again. You wait approximately 20 to 30 minutes until it comes back up on pressure. Check for a leak again. If it starts to leak, just go ahead and tighten it a little more. Let it rest, let it check it out. You're good to go. To apply the patch over the fusible plug, it's fairly simplistic. This does tilt 10 degrees, which is exactly what we need for a fuse plug. The easiest way to put it on there is for him to put the fuse plug on there, the hood. He then lines it up. Looking at this by holding there, he can look it up. I'll lock it in. Move it up to where I want it. At this point, you're probably going to need to screw it in a little bit so you can get a little closer to target it. Right on.
Down. Good. Lock it. Good.
Once he tells me I'm lined up, I'm just going to lock it in.
Don't forget your tool.
As soon as I make contact with the back, I disengage my spring. And tighten straight in. Stopping the leak.
Adjust the cap screw into the yoke until the cap screw point extends slightly below the yoke. Use the paint scraper to remove loose paint and rust from the area. Test the integrity of the sidewall. The strap's length is adjustable to properly fit around the container. Slip one end of the strap under the container and pull it through. Align the strap with the leak in the container. Ensure that the strap is straight and not twisted. If the container is not on a storage rack or rails, then place it on rails, planks, or a similar item to lift the container or dig a trench underneath it large enough to allow the strap to pass through. Position the gasket 9GV inside the patch and set it to the side of the leak. Center the yoke and cap screw into the depression on the top of the patch. Hook the strap to an ear on each side of the yoke. Keep the strap as short as possible. Slide the patch over the leak. Tighten the cap screw 9C1 by hand until the leak stops. Tighten thumb screws until they contact the container, but do not over-tighten. Adjust the thumb screws for stabilization only. Sealing pressure is supplied by the middle cap screw. This stops the leak. Caution: if there is any evidence of weakening of the container wall, immediately discontinue tightening the cap screw. Test for leaks. If the leak persists, further tighten the cap screw. Thumb screws can be adjusted independently to apply pressure on the opposite sides of the gasket to stop leak.
Our final module on chlorine tank car and cargo tank valves and the use of Emergency Kit C is presented by Randy Rowe. Randy is a veteran chlor-alkali industry expert and has trained many first responders. He is the Shipping and Emergency Response Manager for ERCO Worldwide.
Okay, we'll talk about when we first get on scene. You've gotten a call, ChlorEP team hopefully is there. If you're there as a first responder, you're gonna have to be suited up. We're dealing with chlorine. Always protect yourself. Once we climb the side of the tank car, we're gonna have to have a way to determine where the leak's from, what part of the tank car is leaking. So we have to have ammonia. Ammonia gas will react with chlorine gas and make a white vapor cloud. So we have to have a way of determining even if we ever on the right car. So what I like to do when I go up the side of the car is I'm all dressed up. I got my level A or level B. The biggest thing with chlorine, as we've already talked about, is the respiratory protection and cold. Okay, I like my leather gloves and protect my respiratory system. Other than that, I'm pretty good to go. So I take my chlorine or my ammonia gas, We've got a little ammonia in a bottle, a dispenser of some type of a bottle. You can have the liquid ammonia, but all we want is the gas part. Okay, that's going to need to come with me on my first entry. Climb the side of the car. You'll run into the protective housing on the top. That's a sealed housing. It's mandated by law that protective housing is sealed with a 3/16 inch cable seal. If it's not on the car, you need to get off the car. Lots of crazy things happen in our world now, so the biggest thing is protect ourselves. So if that cable isn't on there, get off the car. You can get a hold of the shipper, whether it's an end user or the producer. We always will seal that when it leaves our place. So if that's not there, we need to figure out what's going on. So get off the car. If it is on the car, you're going to need to be able to cut that. Only one way to cut that, cable cutter. Right? It's 3/16 inch stainless steel, so the buck knife ain't going to cut it. Need to have the cable cutter. So that, along with ammonia, is going up first trip with me. I cut the cable, open up the protective housing, and we're probably going to have a mess. Ferrochloride forms inside this car. If it's leaking, it's going to have this brown, gooey looking stuff. So you're going to have a bit of a mess, but you got to try to figure out what is leaking here. Okay, once you open the protective housing, you're going to see 4 angle valves with a valve in the middle. It's called the pressure relief device. All right, we'll talk about the angle valves first. There's really 2 types of angle valves out there. The ACF valve, which is a metal-to-metal seat, and the Midland Dayco valves also are a manufacturer of a soft seat valve. First, I'll explain the ACF valve. This valve has a metal-to-metal seat, has a 1-inch plug in it. There's a metal seat in there, has a packing gland, and the handle on the valve. The easiest way to tell the difference between a soft seat valve and a metal valve and a metal seat valve is the handle. One has holes in it, one don't. The thing with the metal seat is tighter is better. These valves have been around for probably 70 years in service. Good valves serve the industry well, but they did leak. They were a problem. And so tighter, better. So with the holes in it, there's a couple of things that you can use, but a pipe wrench. There is part of the C-kit, which I'll show you a little bit later, that'll actually fit in here, and we can tighten it down tighter. So that's the biggest thing, is figure out what kind of valve you're dealing with. Now you have your ammonia gas with you, so you're going to have to check and see if we can actually find what is leaking, and then maybe we can repair it. Again, we don't want to put the C-kit on. That's the last thing we want to do. So what we like to do as responders is we work from the top down. So we have our ammonia gas. The first thing that you need to check is make sure the valve's shut. Probably 90% of the calls that come in out there that you got a leaky car, it's because the valve ain't shut. So first thing, especially you figure out it's a hand tighten only, just reach around and tighten all 4 valves. Okay, we're going to make sure the easy things get done first. Top down. Shut them all. Check, take your ammonia gas, spray it around, see if you can isolate and figure out what is actually leaking. We're going to go work from the top down. We figure out it's this valve. Remember, there's 4. It's this valve. First thing we're going to check is the packing. As you can see here, this packing nut and Teflon packing, and there's a packing retainer ring in here. This can be tightened down just as tight as you can get it. You can't hurt this packing, and you can't crush it, you can't force it out. This is obviously just cut away here. So if you got a little gas coming out of here, check this nut, make sure you can see if you can tighten it down. Only way chlorine gas can get up into here is if this valve is open or it's leaking through, right? Because it can't get into that chamber. Then we work our way down the valve. This is okay, this isn't where it's coming from. Then this is 1-inch plug. You're gonna have to remove it. Might need to use a pipe wrench because the regulation is that this plug is tool tight. That's the regulation. So you're not gonna reach in there with your hand and take the plug out. So if you remove the plug, got gas coming out of here, the reaction's happening here. It's because the valve's open or it's leaking through, right? So if it's coming out of here, again, make sure this thing is tight. Don't put a wrench on this, because you'll crush this seat in here. You can see it's just Teflon in there, and that'll crush it and make things a lot worse. Tighten it down. You're still getting gas out of here. Take your Teflon tape that's in your toolbox. Put a little Teflon tape on there. Screw it back in, tighten it up, and see if you can get the leak to stop that way. If the leak's not coming through the 1-inch plug, next step down, we're going down this thing. This is where it's bolted to the pressure plate on the car. 4 nuts on here, a recessed ring on the bottom, has a Guylon gasket on the pressure plate. If the leak's coming from beneath it, there's a tool in your C-kit called a crow's foot. I'll show you that in just 1 minute. Gonna try and tighten it down there and try and get that to stop there. So valves are pretty simple. There's not a lot to the valves. Again, these are a little different. We can tighten these down with a wrench. These don't touch them with a wrench. So we talked about the angle valve. There's one valve. It's in the middle of the pressure plate. That's called the pressure relief device. These safety valves are set at 375 pounds. So if the leak is coming from the inside of beneath the valve or through a tattletale, it's one of two things happen. Either this rupture disc failed, the gasket failed, or the car actually has high pressure. What happens if the car does go over 375 pounds, this rupture disc explodes, the valve actuates, releases the chlorine gas. Remember the liquid, the liquid's farther down. The chlorine gas will come out. Once it gets down to 372 pounds, that'll reseat. All right? So when you initially made your entry, maybe you didn't find anything. But yet there's a telltale sign that there was a leak. There's ferrochloride built up inside the pressure plate, but we can't find a leak. We need to figure out what's going on. There's a tattletale on here. You open that needle valve, and chlorine gas comes out of here. The valve had actually actuated. There should never be chlorine gas in that coming out of that needle valve. So we got a problem now. Remember, it's a pressure relief device is on the car for a reason. It's to protect the car. So we can't put a C-kit on it unless we know something. We need to know the pressure on the car. If I put a C-kit on it, I just took my safety device away from the car. Nothing protecting it anymore. There's only two things that can make high pressure on a tank car. One is the tank car was overloaded. Our chlorine is loaded at about 60 degrees Fahrenheit, somewhere in there, and as it warms up, it expands, and it's going to create pressure. So if the tank car is liquid full, all of a sudden there's nowhere to go. Pressure relief device is doing its job. We can't put a kit on it. There's something else that's going to happen, and I'm going to have to do it. I'm going to have to offload it. You're not going to be able to do anything but monitor it. So that's another piece that's a part of the C-kit that we're going to talk about in a little bit, is how to get a pressure reading on a tank car. And the other thing that could be happening is maybe something was introduced into the tank car and there's a chemical reaction going on inside it that the chlorine isn't agreeing with. Some oil maybe got put in the car, or there's some water in the car. So the chemical reaction going on, again, builds up pressure, doing its own job, right? So we got to make sure that the valve is leaking before we cap it. We don't want to cap something when it's doing its job. So that's the valves that are on a car. Chlorine cars are really a basic car. Not a lot to them. 4 valves, 1 safety device. That's it. Okay, I'm going to show you the new generation tank car valves that are approved. They're running out there. There's several people who are putting on new builds now. They are, they can actually convert the existing tank cars to this valve system. So they're out there. And you never know when you climb the side of a tank car. our industry has been, because of the Chlorine Institute and the work that we've done, every time we respond to a chlorine container, they're exactly the same. That makes our job a heck of a lot easier. But now we've introduced to, you know, I also want to keep improving everything, even though we went from the metal seat valves to the soft seat valves, and now for rollover protection, they've built a new next generation angle valve. The big difference that you see is with the angle valve that we just showed you, that is this primary containment, is that angle valve. Is this, what we did is we took the check valve, actually mounted it to the bottom of the pressure plate. So the primary valve, the primary seal is underneath the pressure plate. So if this thing rolls over and this valve gets sheared off, no chlorine comes out. How it functions is very similar to the valve that we already demoed. When you turn this lefty-loosey, righty-tighty, what happens is as I'm opening it up, you can see this stem on the bottom. The valve's kind of heavy. You can see this stem on the bottom. It's actually is going down. So what's going to do is open up that check valve. All right? When I close it, it retracts. Even though I'm still going the same way as a responder, it's important that when I climb the car, closes that internal check valve. So this valve has now become the secondary valve and the plug is third. All right? Pretty unique design. And you'll see them out there. You'll note that inside this protective housing, we're missing a valve. There's 3 angle valves on here, 1 PRD. The only reason that was done is to reduce leak points. It's an option. You can get the 4-valve system or the 3-valve system. The other thing that's changed on this car is the PRD. I explained how the PRD works there. It's still a 375-pound release pressure. The big difference is that the rupture disc is no longer part of the PRD. It's actually part of the pressure plate. The rupture disc is still there. It still releases at 375 pounds, activates the PRD, still functions exactly the same. The big thing is in a rollover, you can shear this PRD off. Again, no chlorine comes out because the rupture disc will hold it. Same functionality, still got the tattletale. Chlorine should never be in here. You open this, you get chlorine out of here, that rupture disc is either exploded or it's fouled and it's passing chlorine gas through. Right? Otherwise it functions the same. This one actually has the bonnet on it. So when you open up the top of the protective housing, if you see this bonnet off, this is dust cap. If you see that that's off, that's another indicator that possibly this thing has discharged. That's how the chlorine's coming out. Once that valve releases, the chlorine will blow that dust cap off and it'll be laying here on the side. Just something to look for. Again, if you see that, check the tattletale, chlorine gas in there. Another thing that's showing you that might have actually released, so we need to find out what the pressure is on the tank car. One other thing that you'll note inside the new generation tank car protective housing are these bars that are mounted in here. What we found when we built the car is that the C kit will fit, otherwise obviously it wouldn't be approved by the AAR. It has to fit. The problem we had is that the protective housing's bigger, and to put the C kit on, when we went to mount the strong back, to get the J hook through the porthole, we had to take the J hook off of the strong back, hook it, and then remount it to the strong back. Well, when in the heat of the moment we're all suited up, that's just way too much. So what we did is we mounted these bars on the inside of the protective housing to hook the J hook on. When it turned out, it actually worked better than anticipated because they'll self-center. So it's actually easier to mount the C-kit into the bars instead of the portholes because they'll self-center, don't have to worry about it getting off to the side. So that's what you'll see when you open up this new gen car. Okay, this is the C-kit. Everything that's laying here on the table is in the C-kit box. I'll go through all the tools and explain the function of them, and then I'm going to tell you what ain't here. All right. Obviously, the bolt cutters, very valuable tool. The first one we need so we can get inside that protective housing, cut that cable. Also, the plugs on the angle valves. If you remember, they have these 1-inch plugs. They're held on by a chain or again, a stainless steel cable. And if you determine that you're going to put a C-kit that has to be installed over this valve, take that, cut it off, get rid of it. We're going to talk a little bit about that in the additional toolbox that I'm going to build for you, but this just gets in my way. Get rid of it. Remember, we're all suited up. Everybody's watching us. All the professional people down on the bottom who have never touched a car are going to give us all the advice we need. So anything that we can get rid of it. Take your cable cutter, cut it, get rid of it. Hammer, if it don't fit, beat it. Okay, have to get that plug out of there. You can use the adjustable wrench. Wrench 200C. You can see we will use this when we're installing the C-kit. Fits on top of the bolts and also fits the valve on top of the can. Be able to open and close the needle valve. Also fits on here to get the plug off or the cap off the valve. Putty knife, very, very important part of this kit. Again, when we open that protective housing, remember I was talking about all the crud that you're going to find in the bottom of it. Ferrochloride builds up. Remember, our chlorine is dry, so once it gets a little moisture, it becomes really aggressive, real corrosive. Dry chlorine, it's a carbon steel tank. Doesn't hurt it. Get a little moisture with it, ferrochloride builds up. As it was talked about on the other kits, we got to have this thing clean. We want to do it once. We're all suited up. Time is precious, but if we got to do it twice, totally wasted our time. Clean, clean, clean. Get it nice and clean on the bottom. Get that stuff off there. Another wrench, the 110 wrench, will actually fit on the packing gland on the ACF valve. The 216, this is will fit on the ACF valve. Remember the one handle that had holes in it? We decided we have two types of valves, a soft seat valve and then a metal-to-metal valve. This will actually fit inside that valve handle and help you tighten that down. Remember, with the metal-to-metal, tighter is better. You can crank that, you can't break it. The 113 wrench also has a 2-part wrench. Got to have the T-wrench in it. The protective housing, there's only one real flange on a chlorine tank car. There's the tank is one piece. It's a big tank with a tank nozzle on the top, and that's where the pressure plate mounts to the tank nozzle, and the valves are mounted on top of the pressure plate. This will actually fit onto the nuts that hold the pressure plate to the tank nozzle. Put it on there, tighten it up. We do it in a star pattern. The only problem we're going to run into is that that's put on at 600 pounds of torque. So if you have a leak at the pressure plate to the tank nozzle, this kit has nothing for it. There's not a kit out there for a tank nozzle leak, right? And we'll talk about that when we get to the protective housing, and I'll show you a few tricks to determine if it is a tank nozzle leak. But this one will fit on them nuts, and we're going to talk about that a little bit more when I talk to you about the additional toolbox that you should build. This is called a crow's foot. It's a 112 wrench. Again, need this part in here. Turns into a T-wrench. You'll note I call it a crow's foot wrench because what it looks like. These valves are held onto the pressure plate. 4 bolts, nuts. So you can see this where they go through. Again, if it's coming out from underneath the angle, underneath the valve to the pressure plate, take the crow's foot, tighten it down, make sure you tighten it in a star pattern. If the valve gets crooked, going to make the whole thing worse. There is a guy line, where it's mounted, there's a guy line gasket in there and it's recessed. So you can tighten that down pretty tight, you're not going to hurt it. The gasket's not going to squirt out on you. Tight is better. You can't over tighten it just with your arms, that's for sure. That gets us to the main part of the C-kit. You'll note the 24A1 has a square bottom and the 6A1 round. If you look at the valves, round bottom, the PRD is square bottom, all right? These things are pretty heavy, so determining what you're gonna do before you go upside a tank car, pretty important. Only take what you need. In front of the, you'll note the Viton gaskets. Nice, flexible, make sure there's no nicks in them. They'll fit on the bottom of the can. They fit really tight, so once you have them on, you're good to go. They shouldn't fall off. But also check for nicks, cracks, wear. Only use them once. If you use them in an incident, don't use them again. Get yourself new, all right? Keep them for practice, right? And again, the round one goes on the round can. I'll show you how to put this on in a minute, all right? Just go through the parts. Here's the strong back that's going to hold this C-kit in place. Sits on top. This is the back part of it. I'm going to demo this in a minute. Strong back goes over the top, hooks in the portholes, and we can tighten it right down. So this is all part of one kit. Building the additional toolbox. One of the first things we're going to need is liquid ammonia. You can buy it down at the grocery store. Any grocery store is going to have it. You cut it though. You keep it in a container that's sealed tight. Otherwise you're going to get to it and it's not there. It evaporated on you. Cut it 50%. Keep it in a tight little container. The other thing you need is a way to disperse it. Okay? It's liquid ammonia. I don't want liquid. If I squirt liquid ammonia into a protective housing that has a leak, I got a big cloud. Okay, I got the right tank car at that point. I can't separate what valve's leaking, where's leaks coming from. So really what I need to use is the gas that comes off the liquid ammonia. So I need a little bottle to disperse it with. I'll get the little one that's got the little plastic tube that comes out of it. Tube comes down inside of it, take the cap off, cut the inside tube off. I don't want that in there because that's just a eduction light that's going to squirt me more liquid out. Cut that off, put it back on. Don't put the ammonia in it until you get on site. Keep it in a sealed container. All right? The other thing I like to have in my little toolbox is a Q-tip, the long wooden Q-tips. Sometimes these leaks, even though you can smell them, are very, very small. So I got to try and find a little bitty leak. If I have that little Q-tip, I can get right down in there. I'll soak it with a liquid ammonia, get right down in there, and I can try and find that leak. So that Q-tip, another way to disperse the ammonia. All right? So I got this toolbox. I got some ammonia. I got a way to dispense it. We have this putty knife to clean up the ferrochloride. I need rags. I need a lot of rags because it's going to be a mess. So I'm going to get in there and wipe it all out, scrape it out, clean my putty knife off, get back in there, keep scraping. So big bundle of rags. Also, the other thing that we need the rags for, once we get inside the protective housing, you'll see there's drain holes on it all the way around the inside. I use them rags to stuff in them drain holes and plug them. One of the things that happens, remember, the chlorine is heavier in air, so it sinks. The pressure plate, remember, there's only one connection. It goes from the tank nozzle to the pressure plate. If I'm down along that pressure plate tank nozzle connection and I'm with my ammonia gas checking for a leak and it's clouding up, it could be the leak is inside the protective housing and it's coming out the drain holes. So I think the pressure plate's leaking and it's not. So take the rags, stuff them in the holes, all right? Got to have rags. Talked about Teflon tape. No Teflon tape here. Another important part so that I can tape up the plug to stop the leak that's coming out of the plug, right? Duct tape. I like to have duct tape, and when you're putting on a C-kit onto a car, the portholes have little flappers on them. Well, take the duct tape, tape it up, get it out of my way. All right? If you're trying to do all this stuff and Incident Command made me put level A on and SCBA, the last thing I knew is to fight that. So I also like to have a little duct tape in there. I'll tape them portholes covers right out of my way. All right? Cheater bar. I talked about 600 pounds of torque onto the tank nozzle to the pressure plate. Give me a big cheater bar, 36-inch cheater bar. I put that on this wrench, put it on the end, get a real big guy, and I might be able to move that.
So a 36-inch cheater bar, have that part of your plan. Pipe wrench, don't have a pipe wrench. Sometimes these plugs, remember, the regulation is tool tight. My tool tight and a guy smaller than me, our tool tights can be different. You might run into one that ain't moving. You know, we got a little bitty wrench to get it out with. Bring a big pipe wrench. Might need that to get it out. Put that in that toolbox. Again, a multiplier. You can buy a multiplier to put on top of this. We're trying to move something that was torqued at 600 pounds of torque. So you can get a multiplier, try to get more leverage on this thing. We talked about cutting the plug off to get it out of the way. Another thing that I carry in my additional toolbox is a 1-inch flush plug, they're called. You can buy them at any hardware store. This is a 1-inch standard thread. A 1-inch flush plug looks just like that, but instead of having this on the end of it, it'll have an Allen head hole in it. So what I can do is take my 1-inch plug, put it in there, take the Allen wrench, again another part that I have to have in my toolbox, tighten that up and it'll become flush. I can put my C-kit over the top of this. Now I have my C-kit becomes my secondary containment. If the thing's leaking, I have to plug in there and I put this over the top, now I got secondary containment. So instead of not having a plug in there, I can put the flush plug in there. We talked about knowing why, before we recap a car, we got to figure out what's going on with it. We have a problem with a PRD, we need to know pressure. Well, again, the C-kit doesn't have pressure gauge. Another thing that I need in my toolbox. We talked about what the pressure rating of the PRD is, 375 pounds. So obviously a 200-pound gauge is no value to me. I need to get a 500-pound gauge. It has to be compatible with chlorine gas, right? That should be part of it. Doesn't need to be a certified gauge because we're just looking about. I need to know about the pressure. If it's 200 pounds, it's not a problem. If it's 350, I'm not capping that. So get me a 500-pound gauge, and of course I have to have a way to connect it. Again, this is a 1-inch standard thread plug. So I'm going to get me a 1-inch pipe about 12 inches long. I'm going to get me a 500-pound gauge, big face on it. So when I screw it into the side and I point it down, because you know what the incident commander is going to want to know. He wants to know the pressure of the car, and I want to know it every 30 minutes. So you have two options: climb the car or have a big face gauge and point it straight down so I can walk up the side of the car and look up and I can see what the pressure is. Another thing that's not in here. So build that toolbox, put it in there. Anything else that you can think of as time goes along that you'll need, put it in that toolbox, have it set up with your C-kit, locked up so it's ready to go. Okay, now we're going to demo putting the C-kit onto the tank car. We've already determined that the angle valve is leaking. We've tried to stop it. We've failed to do so, so we're going to put the C-kit onto the tank car. So we talked about the first thing we're going to do is clean up the pressure plate. We got the putty knife that was part of the kit, rags that weren't part of the kit, they're part of the additional kit that you built. He's going to clean up that pressure plate. Take your time, do it once, get it really clean. We got to get a good seal on it so it gets all the ferrochloride and gunk and everything cleaned off. Again, it's the angle valve, so we need can 6A1. Okay, I'm going to remove the cap off the valve. Check to make sure that the valve is open. Should always store it open, but always check it before you put it on, because remember there's a leak, so it's going to build up pressure and it'll build up real fast and the thing will start jumping on you. The 1-inch plug he's actually set up on top of the bottom on the angle valve. And when he's positioning the can over the top of the valve, he wants to make sure that the valve is accessible so that he can pull the pressure off the can at a later point when we want to remove it. We're going to trap chlorine gas underneath it, so make sure that it's accessible, not up against the protective housing. So now he's got it in position. We're going to put the strong back over the top of it.
When we're mounting this in, it's easier with two guys. Again, we got to get the J-hooks through the portholes. Once you have the strong back in place, want to try to get it positioned so that the J-hooks are in a vertical position so it doesn't pull on it from one side or the other. Now he's stunging up the bolts on the 11B. One thing to remember on these bolts, do not lube them. All that's going to do is attract dust, and then it's just not going to work. Keep them dry. When they come from the factory, they'll spin in nice. You start lubing them, pretty soon you got dirt in the threads, and it just ain't going to work again. So you're going to take the screw 11C, screw it into the 11B block, and what that's going to do is tighten everything up. It's going to bring the strong back up. It's going to take the J-hooks, snug them up into the portholes, keeping everything all in line. The function of the screw 11C is not to hold the can in place or tighten it down onto the pressure plate. It's actually just to hold everything in line, get everything lined up so that the J-hooks again are vertical, the strong back straight. So he's got it snugged down with 11C. Now he's running the 4 bolts on the 11B block. He'll run them down onto the top of the can. Now once they're hand tight, he's going to take the wrench 200C and start tightening down the bolts. You'll note that he's going in a star pattern, one side to the other side, back and forth, and you're going to do this several times because that Viton gasket is going to start squeezing down onto the pressure plate. It's really important that you do it exactly the way he's demonstrating it. A little bit on each bolt, a little bit at a time. Keep cranking it down till you can feel it'll start tightening up. That Viton gasket, it's pretty pliable gasket. They're pretty tough gasket. It's pretty hard to cut them. You got to crank pretty hard to cut them. So we're going to get it down there nice and snug, and he's probably getting real close to where he needs to be. He's got it nice and snug. Okay, once you got it all tightened down, the next step is we're going to need to take and shut that valve. It's important now because once you shut that valve, we're going to start building pressure up. So you'll note that he stays off to the side. He's going to shut that valve and the pressure starts building up in the can immediately. So make sure your body ain't over the top of that. Could have 200 pounds of pressure in that can pretty fast. That thing comes loose, you never know. So stay off to the side. It's going to tighten that down using that same 200C wrench. Once he has that tight, we're going to grab that ammonia bottle and go around, make sure that we got nothing, no leaks. Got no leaks, we're good to go. The incident commander, he's going to ask you to go back probably 30 minutes, 15 minutes later and check and make sure that you're still leak-free. Climb the car, you got your ammonia, check around the can, check by the valve, make sure nothing's leaking. If it is leaking, we're going to need to relieve the pressure off that. And again, we got the valve positioned so that we can actually use it. Hook up a little tubing, run it into some caustic, sparge off the pressure off that can. Don't work on it when there's pressure on the can. Sparge it off, take the pressure off, leave the valve open, go back, get the wrench, the 200C wrench, and you can start tightening down on the 4 bolts on the top again. Tighten it up, go through the whole scenario again, shut the valve, check for leaks, and should be good. That's the way it's mounted.
Device 6 will not fit on some of the alternate valve designs. Device 24, traditionally used for the pressure relief device only, will need to be used instead. Also, an additional tool, a 1-inch threaded stabber pipe not included in the C kit, will be needed. Loosen and remove the 3 cap screws securing the valve outlet flange to the valve body. A 1-inch threaded stabber pipe needs to be inserted through the housing port near the leaking valve. Thread the pipe securely into the valve outlet flange. Tap the stabber pipe on the sides with a hammer until the valve outlet flange is loosened. Remove the stabber pipe with the outlet flange attached. Hood 6A1 cannot be used on these valves. Instead, 24A1 must be used. You may have to install the emergency C-kit hood 24A1 over a pressure relief device with a telltale valve and plug. This telltale valve will either need to be removed or rotated to allow clearance for the installation of the 24A1 hood.
One of the things that I didn't talk about that we should is the Chemtrack network on the side of the tank car. Great big yellow sticker, can't miss it. It's a Chemtrack network that'll dispatch our ChlorRep team. We'll respond to all chlorine incidents. We'll get a hold of you on scene. We can help you over the phone, try to figure out what's going on with the tank car. Meanwhile, we're en route, and we also respond. It's not a question. We're on our way as soon as that phone rings. The last thing we want to do is put this C-kit on. We talked about how to find leaks and how to stop leaks, but once that C-kit's installed, this tank car is not going anywhere. It's going to take a one-time movement approval. It's probably not going to happen. The best you'll do is be able to move it a few miles, maybe to a production facility to work on it there, but you're probably going to work on it where the tank car is. So we try not to use it, but you know how to install it. So everything that we taught you, hopefully you can use in a safe manner.
We've covered a lot of ground. We've examined the properties of chlorine, tank car and rail safety, how to apply emergency kits to 150-pound cylinders, ton containers, and tank cars and cargo tanks, and general emergency response. As a first responder, you play a critical role in the unlikely event of a chlorine emergency. But you are not alone. The ChlorRep network can be activated anytime, day or night, by calling Chemtrack at 1-800-424-9300, where you will be connected with the nearest ChlorRep team member that can provide vital information and in-person assistance if needed. Also, check out the TransCare webpage for even more resources. In addition to these training videos, we have included each module's PowerPoint presentation, complete with presenter notes, on the DVD. You will also find additional information in the extras folder. We hope you have found these presentations valuable and the information beneficial to your role as first responders. So let's get going. And remember to wear your PPE. Thank you and stay safe.